Hello grade 12s, welcome to my channel. Today let us have a look at this paper from KZN. It was quite heavily requested, so let's see what's hiding in this paper. It's better cry nice in this color. Alright, instructions guys, I cannot overly emphasize them, but familiarize with these ones and essentially commit them to memory, because these ones can decide whether you're getting full marks or not. Otherwise, do read the rest and familiarize yourself with how this paper is so special from the others. Question 1, statistics. Okay, easy stuff. Now, Mr. Sipokazi, once you have that kazi at the end, esasimamva sichaza ntoni isikhomokazi, right? And that's why bezathi Mr. Qumba bathi nguSiphokazi. Hayi, kanimeni kancinci. Mr. Siphokazi supplements his pension by mowing lawns for customers. Okay, he measures the areas in meters squared, and obviously that is the x variable of 12. Again, pay attention to totals, guys. Totals are very, 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 very important to ensure that you have gotten them under control. So there's 12 area of his customers' loans and the time y. Again, can you see it in minutes? So always take care of the unit of measurement. It takes him to mow these lawns. Okay, he works 8 hours a day. Okay, that's all right. So he recorded the data. So this is bivariate data. So we're going to do the least squares regression stuff here. So let's just go into the business. Okay guys, so technically the business here is to go to mode on your calculator. You select stats and then that ABX, which is the least squares regression line. Get a table, you fill it up. Then you press the AC button to sort of store the data. Then the procedure is shift. You press button number 1, then you choose regression and any one of these parameters. Okay, so let's do 1.1. 1.1 says determine the equation of the least squares regression line. So we need A, we need B, and therefore our equation will come in. So you just input this data onto the table, then we go shift 1, regression, we choose A, and then my A comes out as 28,14. Remember, we were told in the general instructions to 2 decimal places. Then we repeat the process for B, which becomes our gradient. So this is 0,0 to 2 decimal places is 0.9. Therefore our y accent is 28,14 plus 0,09 x. Okay, so that is our least squares regression line. Nice and easy. So we're getting a mark for those and for putting it together. Next question. Calculate the value of R. That's the correlation coefficient. So we go same procedure, shift 1, regression, and then we press R, and then R here 1.2. R is going to be 0.91 to 2 decimal places. Okay, usually that's all you're going to do with the calculator here. So we're getting 2 marks. And then we're told here, given that Mr. Spockers charges a flat out fee of $150. So that means calling him, this is what you should be prepared to leave from your pocket. Now, as well as 50 per half an hour or part thereof, meaning even if it is less than half an hour, he charges 50 rands. Now it says estimate the charge for mowing a customer's lawn that has an area of 560. So that's fine, we can do that easily. So 1.3, we know that y accent is going to be 28,14 plus 0,09 into 560, right? Because that is the x value. But remember, this is in minutes, so it's going to give us this in minutes. So let's see. We've got 28,14 plus 0,09 into 560. So what do we get? So I'm getting a 78,54 minutes, which when we divide by 60 minutes to make up an hour, because we know he works for hours and we're talking half an hour day. So this becomes a 1 hour, 1,31 hours, meaning it's 1 hour and 30 minutes, some change. Okay, so that's fine. So we can say here, therefore, the total cost for this outing is going to be equal to the flat out 150 bucks, right? Because when you call him, you must be sure you're paying 150 plus. Now this is an hour. An hour is 2 times 30 minutes, so basically 2.5 hours is going to be 50 times 2, right? Because that's the amount we are paying there. Plus again, we've got a 30 minutes there. This is 31 minutes, so that's going to be essentially another 50 bucks. So that becomes what? This is 150, becomes 250 plus 50, it's 300 rands. So that is what Mr. Spoggers is going to get paid for this. Okay, great stuff. So it's a nice question. You always get a question like this. Now what are we getting here? Of course, the substitution is important, and essentially getting that value. I'm not sure if that value is really necessary, is it? But yeah, this answer is correct, so maybe let's just mark that one and say that's it. Okay, 1.4, we're told here the local high school wants Mr. Sipogazi to mow their rugby field, which is rectangular. That's great. And it is how many meters long? 100 meters long. So that's the length. And it is 70 meters wide. That is the width. Okay, great. It says now use the regression equation found in 1.1 to calculate the time it would take to mow this area. So we've got 1.4.1. This is easy. Y accent is 28,14 plus 0,09 multiplied by, now the area is going to be length by breadth. So this is 100 times 70. Okay, so we want to know how long this is going to be because we just want the time. So this is basically 28,14 plus 0,09 into 100 times 70. So calculators can handle this. So I'm getting a 658,14 minutes. Okay, that is fine because we were given our time in minutes, so we're not going to bother ourselves converting. Now that is it. So essentially calculating this area is what is important, or perhaps just the answer, because we're getting just 1 mark. Okay, we became a bit stingy. Now 1.4 says, is it possible for him to complete this job in a day? Mind you, he can only work for 8 hours. So give a reason for your answer. Well, let's just say the total time is going to be 658.14 minutes, which is essentially, when we divide that by 60 to make it an hour, this is basically 10.97 hours. Right, so that is beyond 8 hours because he can only work 8 hours a day. So we can say, therefore, he will not know this time is more than his daily 8 hours of work. Okay, so that's it, because we can see that essentially Mr. Spogazi can only work for 8 hours, and now this takes him to 10 hours, essentially 11 hours. So he won't be able to finish this one in a day. So we're getting a mark for our stuff there. And we're taking those easy 10 marks. So ngama cry nice, ne? Ngama cry nice. Okay, so let's move on to question 2. We always get 2 questions on stats, right? Now question 2, we are told here, the following table gives the frequency distribution, the daily traveling time in minutes. Again, pay attention to the unit of measurement from home to work for the employees of a certain company. Now we can see we're dealing with grouped data here. Of course, this table is already trying to tell us that we need to fill it up. So let's just fill it up nicely. What happens is we just want the midpoints of those values. So this is 5 and 10. So just say 0 and add 10. Then you divide by 2. That gives us 5. Okay. And then this one is going to be 10 plus 20. That's 30. Divide by 2. That's 15. This is 50. Divide by 2. That's 25. That's 70. Divide by 2, which is 35. This is 90. Divide by 2. 90 divided by 2, 45. Yes, something like that. And then here we know that we always get these frequencies when we multiply the midpoints and the frequencies. So this is going to be 20 times 5, which is essentially 100. And then here we've got 35 times 15. This gives us a 525. So this is 30 times 25. That's 750. And then we've got 10 times 35, which is 350. And then we've got 5 by 45. That gives us a 225. And then of course we need the totals. Right, what would be that total? 225 plus 350 plus 750 plus 525 plus 100 gives us a 1950. Okay, and we also need the total here of the frequencies. How many are these dudes? So this is going to be 20 plus 35 plus 30 plus 10 plus 5. That's 100 people. Okay, so great. This table, you just fill it up without wasting time. Now the first question says calculate the estimated mean traveling time. So that's easy. 2.1. All we're going to do, we take the total here. So we know that the mean is x bar is going to be whatever. Don't write a formula there, it's not necessary. It's 1950 divided by 100. So let's see, 1950 divided by 100 is 19.50 to 2 decimal places. Remember, this is minutes because we were given this in minutes. So this is the mean traveling time. Quite a lot, but 20 minutes is not too bad. Now it says write the model class. The model class is one with the highest frequency. So if we scan these frequencies, 35 is the highest. So we will simply write that one. So this means our x is less than 20, greater than or equal to 10. That is our model class. So that is 2 marks. Easy 2 marks. 2.3 says an ogive. Remember, this word is red ogive. Okay, an ogive is drawn for the given data. Construct a box and whisker plot for the data in the answer book. Okay, now we need to work on our diagram a little bit before we can get to that. So first of all, we need 50% of our data, which is that one day. Okay guys, so basically what we need is to find 50%, because then that gives us Q1. Can you see this is just before 20? So this is probably 18. This is Q2, ne? And then half of the data above Q1 is basically 20. If we see this is 20, 25, 30, so this is around 27. So we know there that this is Q3, which is 27 approximately. Of course, we're just working with the best that we can find. And then the lower half of the data, which becomes a Q1, you can see this is 10. So this is round about 12. So we can say Q1 is 12. Ne? And then we've got our minimum here. The minimum is going to be the anchor. As we can see, the maximum is essentially what goes with the totals. So that becomes our maximum value. Okay, so essentially there's our 5-number summary: minimum, Q1, Q2, and then Q3, and then the maximum. So all we have to do now, I don't have the grid unfortunately, I'll just create my own. Okay, so there's our lovely grid. Now what we need to do is to focus on Q1, Q2, and Q3. This is around 12. So 12, according to our scale, is probably there. I don't know why it's writing. So 12 is around there. Okay, so that is about where 12 is. The only problem with this question paper, paper 2 is demanding in that it wastes a lot of time. So there is 12, and then Q2, we want it to be 18. This is essentially just before this one. So there is 18, maybe. And then we want Q3, which is around about 27. So this is halfway, 25. 27 is somewhere here. And then once that one is sorted, our lives are essentially easy to. So all we do, we just deal with this problem nice and easy like that, ne? And then we've got our whisker going to the maximum. I don't know what I wrote here. So this is basically at 50, and then our minimum goes to 0 because here we don't have much. So that is essentially our box and whisker. I don't know if we have to write Q1, Q2, Q3, max, and minimum, but that is essentially our box and whisker diagram. So how many marks were we scoring there? 3 marks. Nice and easy. Nice and easy. You can actually fill in these parts here and say probably we need to show that that is 12, and we also need to show that that is 18, and essentially this is 27, so that no one asks silly questions and say what the hell. Anyway, let's go on, guys. So 2.4. Now we're told you state whether the following statements are true or false. the distribution of the traveling times is positively skewed. As you can see here, there is more area in this space than there is area in that space, right? So obviously this is skewed to the right. So this is true. So this is 2.4.1. The answer is true. Okay. 2.4.2 says the interquartile range is 25. Well, interquartile range is IQR is basically Q3 minus Q1. So this one was 27 minus 12. So what that is, what is that? 27 minus 12 is 15. So 25 is too big. So there's no way. If it was just a digit from that, probably would accept. So the answer is a hell no. It is false. Now, 35 employees take less than 20 minutes. So let's see. Is that so? Let's look at 35 on our O drive. So 35, this is 10, 20, 30, and then 35 is over there. So let's go to the cumulative frequency stuff there. So you can see this is almost 15, and essentially that is not 20 minutes. Oh, by the way, it's less than 20 minutes. So the question was 35 people take less than 20 minutes, and that is essentially true. So 2.4.3, this is, oops, I was so happy to say false. So that is it, guys. So you're getting those easy 3 marks. You just have to interpret your data, basically. That is the skill here. Again, 11 marks, ngamakrai naisla, grade 11 stuff. There's nothing really out of the ordinary there. Okay, guys, let's get to some more serious stuff. So we've got question 3. Now, this is what is going to hurt a bit. But NB here, how do you approach this question? You do the doctor's approach. If you don't know what this is, ngiyawusizela ngoba kuzogedla amazinyo bese kuyiwa wagoqa nyawo. Uyayiva yonke lento. Okay, so essentially this one is easy, grade 11 analytical geometry. So we're told the a trapezium ABCD. So what do we know about a trapezium? A set of 2 sides are parallel. Now it's drawn below with AD parallel to BC. Okay, now we can see there is AD, it's parallel to BC. Okay, now the coordinates of the vertices are A, 1 and 7, B, which is Q, and of course this one might be the question. C is minus 2 and minus 8. Okay, D is minus 4 and minus 3. And then we're told BC intersects the x-axis at F. Okay, so that's fine. So x at F goes with 0, because if this intersects the x-axis, it means it's an x-intercept. Okay, so that means the y-coordinate is 0. Then DCB is alpha, so it's indicated. AD intersects the y-axis at E. Again, what does that tell us? It tells us that this is going to be 0 and some y value, because when a line cuts the y-axis, this is the y-intercept. Okay, great. So now that we've seen and observed that we are given information in that manner, what can we do with it? So we can see that on AD we've got 2 points. So from those 2 points, we can calculate the gradient of that line. And using the gradient and one of the coordinates, we can actually find the equation of this line. And from that equation, we can read our y-intercept of that line, which would be the constant. And we can actually work out the x-intercept of that line. That's what we can do. And even find the angle of inclination. Okay, so again, we've got 2 points on DC. That means we can find the equation of this line by finding the gradient and using any one of these points. And from here, that's just about what we can do. And here, essentially, we can see that that line is parallel to this, suggesting that the gradient of BC is the same as the gradient of AD. And from that gradient, using C, we can find the equation of this line. From that equation, we can read out the constant term, which is the y-intercept, and it can help us to work out the x-intercept, even its angle of inclination. So there's a lot we can do. But would we be able to find B? At this point, we don't have so much information, so it still remains elusive. So B, we need more information before we can find those coordinates. Okay, then we put it to the test. So question 3. Now question 3 says determine the gradient of AD. That's a very easy question. So we know that the gradient of AD is going to be y at D minus y at A divided by x at D minus x at A. That's giving us a sabotage. Okay, y at D is minus 3 minus y at A is 7 all over x at D is minus 4 minus 1. Okay, this is minus 10 divided by minus 5, which is basically 2. Nice and easy. So here is just the substitutions and the answer. Easy stuff. Now 3.2 says determine the equation of BC in the standard linear format. See, the most important thing is that the gradient of BC is the same as the gradient of AD. So we can start then, say MBC is equal to MAD. Why? These are parallel lines. Parallel lines. Parallel lines have equal gradients, so this is basically 2. Okay, so we can say then BC as a line is such that y is equal to 2x plus c. Now we can see that through point C, which is minus 2, is 2 minus 8. When we substitute that point into this equation, we will find out that our C here becomes, this is minus 4. When we transpose, it's a plus 4. Minus 8 plus 4 is minus 4. Therefore, that equation of BC is 2x minus 4. Does this make sense, guys? The answer is yes. This is a positively skewed gradient, so to speak. It's a positive gradient, so that is good. And we can see the y-intercept is on the negative y-axis because that's a minus 4. So we can see here that that point there is minus 4. So that makes a bit of sense, doesn't it? Yes, it does. So where is the marks? Basically noticing that that gradient is like that is good, and then this substitution is important in the final finish. So that's how we score those easy 3 marks. So let's go 3.4. Says determine the coordinates of F. Now at determination, you know that you've got 2 options, either by inspection or by calculation, depending on what you can do. But the most likely one is to do a calculation here. So we know that F is the x-intercept of BC, right? Such that we take that equation that 0 is going to be 2x minus 4. Therefore, x at F is essentially, we transpose that, it becomes 4 divided by 2 is a 2. So we can say therefore point F is basically 2 and 0. Nice and easy. So this is just applications of functions. Ne. So sometimes it helps to say a few things, before you show up with certain things that are a bit strange. So here I can give you 2 marks. I mean, why not? Or essentially we can say this substitution and this determination. That's what usually would work. Sometimes the answer doesn't score a mark depending on where the marks are hiding. Ne? Yeah, this is 3.3. This is 3.4. Okay, so let's go for it. We're told now AMCD is a parallelogram. So where is that? AMCD, okay, with M on BC. Okay, that's fine. So let's see if that's a parallelogram. So we can create something like this. Just something that looks like it. And of course, those two are parallel, and then these two should also be parallel. And then that is basically M, which is X and Y, because we don't know what those coordinates are. Okay, determine the coordinates of M. All right, so you can see here 2 marks. You don't really need to sweat here. So we just need to apply our symmetry here. So what I would like to propose is for us to focus on this portion. Let's look at this point D when taken to this point C, because this is what will help us to gauge what is going on here. So let's see. Can you see? To take point D down to C, what did we do? We moved in this horizontal distance. So this is -2, that is -4. So that means we moved 2 units, right? Right. So that means also to move from A to M, it has to be 2 units, right? Right. So this is -4 plus 2 units. It gives us essentially a -2. So that's what we're going to do here also. We're going to say 1 plus that 2 units. It gives us a 3, right? Because we just simply take these units and we add to that x coordinate of A. It gives us that coordinate at M. And then we do the same and say, what about the Y? We moved from 3 to -8. So that's a distance of 5 units, right? Right. And then we do the same thing. We saw that we actually said -3 minus 5 to get to -8. So we're going to say 7 minus 5. That gives us a 2. So basically we can just do it by symmetry here and not sweat anymore. So 3.4, we know that our M is going to be 3 and 2. This is by inspection. If someone is nosy and asking a lot of questions, sometimes you just look at the question, look at the mark allocation. It gives you an indication of how much sweating must you do there. So this was a means to an end, so we remove it. Okay, maybe we can leave that point M. It doesn't hurt anybody there. Okay, we're told to show that alpha is 48,37. Now that's a bit of a question for grade 12, it's not really a difficult question, but a question like this always demands some actions from you. Now let's see, what is the best way to structure this? For me, I would extend this line into the x-axis and maybe beyond. Okay, okay, so why am I doing that? I will explain just now. So an extension, remember, was not there, so I'm extending things. So now I'm going to say, look how many points I've got. I've got A, B, C, D, E, F. So I can call this point here on the x-axis G, and then maybe that one H. Okay, maybe let's remove this G from this side because we want to use this as a means to an end. So what do we want? We actually are interested in this angle. We can call it beta. So whatever you do, guys, show it on the diagram. Why am I doing this? Just watch. So a bit of creativity there will be useful. So can you see that's an exterior angle of this triangle right here? And I know that I can actually find the angle of inclination for this line because I've got the gradient, right? And that angle of inclination is the same as this one. Why? These are vertically opposite angles. So that means finding this angle is essentially finding that angle. And can you see, I have 2 points on DC. So I can actually work out that angle. From there, I use the exterior angle of a triangle to solve this problem. So essentially, guys, to answer 3.5, what do? We can just say draw DC produced to H as shown. Obviously, you're going to have whatever statement you are suggesting, it's going to be evident in your answer book, right? Please make sure of that. Sometimes you don't need to say more than is enough. Even here, you can suggest that such that the angle of inclination such that beta is an angle of inclination of CD or DC. Okay, maybe a few statements are pretty good, you know. That's how you do it in maths. So a bit of life skills will help us. So we can say here in triangle, we can see now this is going to be GCF. This is the triangle that will help us to solve this problem. What are we looking for? We know without a shadow of a doubt that essentially angle, say GFC is equal to basically the angle BFX, right? Because that is the angle of inclination of BC. Why is that? This is vertically opposite angles. Okay, so it's always nice to sort things out. But now what is that? It is basically the shift 10 of the gradient of BC. Is it not? Yes. So this is the shift 10 of 2. Is it not so? It is so. So that helps us to just maneuver into that. So this is the shift 10 of 2. So this gives us a 63,435 to 2 decimal places. Always don't round off to 2 when you are doing intermediate steps. What do we know also in this triangle? We also know that basically 10 of beta is essentially equal to excuse, the gradient of DC, which is going to be, I'm just going to jump in. I'm sorry, guys. My health is not at the very best shape. -3 there. And then we've got -2 minus into -4. Okay, now I'm not going to waste time. This is going to be, beta is going to be the shift 10 of whatever we've got in there. So this is now -8 minus into -3. divided by minus 2 minus into minus 4. Sometimes use your calculator to relieve yourself because it can be a little bit silly. This is basically minus 5 divided by 2. So this is minus 5 over 2. Okay? Alright. Okay, so go shift 10, the answer. You know these calculators are fancy, man. But now it gives us a negative angle, so we're going to have to take it from 180 degrees minus whatever we've got in here. So it's going to be 68,199 degrees. So all I'm just going to do, I'm just going to add 180 there. It gives me a 111,801 degrees. Okay, that was better there. So now we can say safely then. So these questions are a bit of an essay, so don't underestimate them. What do we know, folks? We know for a fact that angle alpha plus this angle GFC must give us beta. Why? This is an exterior angle of a triangle. We've already stated it in our topic, so we don't want to sweat. This implies that alpha plus, we got this one is 63,435 degrees, is equal to beta. We got 111,801 degrees. Therefore, our alpha is this 111,801 degrees minus 63,435 degrees. Alright, so 111,801 minus 63,435. Now that gives us a 48,377. Now round it off to the 2 decimal places. So the answers, you only round off to them like that. Okay guys, the approach can be sometimes tiring and long because it depends on how you saw this. Otherwise, these questions can be a bit of an essay, so you need to be very good at planning and knowing how to attack. So definitely we proved it. So that was 4 marks. So obviously getting this is important, and this was a calculation on its own, but it was a means to an end. I would suppose here that the next piece of information is the substitution here and the answer. Okay, the rest is essentially your problem. Okay, let's finish up this question now. 3.6, we're told to calculate the area of triangle DCF. Where is that? Okay, let's find this triangle. So D to C and to F. So I'm just gonna outline it light blue. So it's always nice when you've got some nice pencils that are colored, because that helps you a lot. So looking at that triangle, so we can see that we found the coordinates of F, that this is basically 2 and 0. And we've got all the coordinates, so we just need to find this side and this side, because we've got an included angle that we just calculated above. So we can simply say in triangle DCF. What can we say there? We know that basically DC is going to be the square root of x at D minus x at C, all squared, plus y at D minus y at C, all squared. And then we substitute. So x at D is minus 4, minus x at C is going to be plus 2 all squared, plus we've got y at D, it's minus 3, minus minus is going to be plus 8 all squared. So there we just punch it in the calculator. So question 2 bafowethu, paper 2. Inkinga ka paper 2 is that ngumude isibhamu seyinyoni, intwende ecaphukisa nyani, ngoba ubhala uze ufuna ukukhala up. So we're getting the square root of 29 units. Okay, so that's fine. And then we can say also we want CF. CF is going to be essentially the square root of x at f minus x at c all squared plus y at f minus y at c all squared. Okay, and then we substitute stuff, and then let's see, x at f is basically 2, minus minus is going to be plus 2, plus into y at f is basically 0, minus minus is going to be plus 8 all squared. So let's quickly do it. The square root of 2 plus 2 squared plus 8 squared basically. So this is 4 root 5 units. Now once that is sorted, we can say then the area of triangle DCF is going to be half. We're going to use the area rule, CD times CF times the sine of alpha, which is the included angle. So this is 0.5 into CD is square root of 29 into CF, which is 4 root 5 times the sine of 48.37 degrees. So we just sort it out. So 0.5 into square root of 29 into 4 square root of 5 into sine of 48.37. So now here, be careful of your brackets. They can be quite overwhelming. So this is 18 square units. All right, so the only problem with these questions is that they are long and very tiring sometimes. But what can you do? There's nothing you can do, guys. You just have to go with the flow or you die in the process. That's it. So you're getting a mark for that, a mark for that, and then the correct substitution into the area formula, and the final mark. So these 17 marks, giving a mark cry nice, to be honest. Except for question 3.5, you needed to be a bit creative there. Okay, let's move on to question 4, which is more of a grade 12 question. Because now that one is a naughty question. It's usually very long and it's quite naughty. The type of questions, they are silly. Let me drink some water. Okay guys, so we still apply our doctor's approach here. The equation of a circle is given as that. So this is the expanded form. So for you who is a grade 12 student, it's always important to do this by completing the square. Because if you don't do it that way, this thing will not make sense. So basically take x, and the sign between x and the x term is minus. You take half of that, this is 4. And then this one is going to be y. You take the sign between y and the other y term. Then you take half of that, it's going to be 3 all squared. Then all you do, you just take 15 and then you add 4 squared plus 3 squared. That gives us 40. So this one should be second nature, guys. Completing the square is not being tested here, it's being applied. So even if you didn't show it, this is critical. So please don't hang around the bush when it comes to this. This thing is tiring. It says now show that P lies on the circle. So that's easy. That's easy. So here there's nothing to analyze more than what we just did. So we've got 4.1 where we have x squared plus y squared minus 8x plus 6y equals 15. Now to answer 4.1.1, we know that if p is 2 minus 9, when we substitute in the x is 2 all squared plus minus 9 all squared minus 8 into 2 plus 6 into minus 9 equals 15. Therefore, so basically when we substitute this point, the left hand side has to equal the right hand side. So we've got 2 squared plus minus 9 squared minus 8 into 2 plus 6 into minus 9. So that basically is 15. So we can see that 15 is equal to 15. If that is the case, the left hand side is equal to the right hand side. We can say therefore P, which is 2 is to minus 9, is a point on the circle, right? Since the left hand side is equal to the right hand side when we substitute. Okay, I don't know guys, there's a lot of things you want to say. Some questions are cumbersome. You just don't know whether you've said enough or you've said too little. It's up to how you see it. So in my point is that substitution is important, and probably that comprehensive conclusion, if at all it is significant. That's what we do. So let's go 4.1.2. Says determine the equation of a tangent to the circle at this point. Okay, now this is where the situation becomes a bit hot, because now you don't have this circle, don't even know what it looks like. Now can you see completing the square is very important. First of all, we say let the circle center be. Okay, maybe let's just say the circle is such that, now we're going to write it in that format. So we know that it's going to be x minus 4 all squared plus y plus 3 all squared equals 40, right? So we can say therefore the center of this circle. Now let's say we don't know anything. This is P, and essentially we've seen there's a Q there, so we can say PQR. So we can say the center R is going to be 4 and minus 3, right? Right, and then the radius of the circle is the square root of 40. We leave it as such. So now that is very important. Now let's have a look at this circle. This circle has a positive x coordinate and a negative y coordinate. So on a Cartesian plane, because this is analytical geometry, this is a point in the fourth quadrant. So I'm just going to show a point in the fourth quadrant, because we've got a positive x and a negative y. So if this is our center, okay, maybe let's just draw the thing. We don't really care to be accurate, but its position is very important. So we can say maybe safely, there is our point R, which is going to be 4 and 3. So that is just essentially a sketch to assist us, because once they are not giving us the sketch, it's always easy to run into problems. And then now, what are we looking for? This point P also is a point in the fourth quadrant. So essentially, if that is, okay, my coordinates are not correct here. So this is minus 3. Now basically, this point P, we can see there that it's having a smaller x coordinate and a very large y coordinate on the negative. So this is probably a point P there. So that point P is 2 is to minus 9. So now when we're looking for a tangent line to that point P, So basically, this is the stuff that is probably doing things like that. Ne? We really don't care, but all we want is to have a picture of what is going on. And obviously, we know that the tangent and the radius, they meet at right angles. Right? So we know that the radius of the circle is going to meet the tangent at right angles, and we already have the coordinates of point P. All we need is to just find the gradient of the tangent and use this point. So we are sorted. So with a sketch, it makes life a lot easier. If you don't put a sketch, that makes a little bit of sense. Uzokhala mntanami. Mina bese ngiyakulaha ke mase ngiqeda lapho ke mina ngiyakulaha impela. Now what we can say here is that, well, the gradient of the tangent, we don't want to waste time, multiplied by the gradient of the radius. Maybe the radius is going to be our PR. Must give us -1, sorry. Why? We know that the tangent is always perpendicular to radius. We don't want to say too much. So this implies that the gradient of the tangent into, now what would be that one? So we're just going to jump in. It's going to be -3 plus 9 divided by 4 minus 2 equals -1. Therefore, the gradient of the tangent is, now let's just see what is that value there. -3 plus 9. -3 plus 9 divided by 4 minus 2 is a 3. So when we divide by 3, we get -1/3. Okay, does that make sense? Yes, it's a negative gradient, so it means our sketch is not really a mess. So we can say here safely, then the tangent line is such that y is equal to -1/3 of x plus c. Now we know that point P lies on the tangent. 2 is to -9 because that's the point of tangency. So this is going to be -9 minus 1/3 into 2 plus c. Therefore, our c is what? So this is -9 plus 2 over 3, basically. So this gives us a -25 over 3. We can say, therefore, the tangent line is defined by y equals -1/3 of x minus 25 over 3. Obviously, this is a negative y-intercept. We don't care how big it is or small it is because our sketch is not drawn to scale, essentially, so don't cry about it. But we've got a negative gradient and a negative y-intercept, so for me, I will accept, because from my sketch, I am able to tell that my operations are not too bad. So essentially, guys, what is key is writing this equation in that format and following by writing that center, because that center was very important. And from there, working out this gradient of the radius is important. And then substituting into this equation is important. And the final finish, how many marks is this? 1, 2, 3, 4, 5. Okay, maybe let's give you an extra mark there for the gradient. So this is how you plan a question like this. As you can see, it's one of those questions. It's one of those questions that are not very friendly. Okay? Akusingama cry nice ke lawana. Gama cry hard. You will cry blood. And yeah, it's just as bad. Now it says a tangent is drawn from Q. Again, see that from Q to this circle. Calculate the length of the tangent. Oops. Okay. Not a problem. But what do we notice here? We will notice that essentially this tangent is also drawn from this is a negative x and a positive y, so it's from the second dot. So yes, let's draw the sketch again, because without a sketch bafowethu ngiyakutshela ke mina uzovele bese kuyakhalwa nje izinyembezi nje sithubeni nje. And ke thina ke sesikhathele zizikhalo, sifuna abantu aba-charismatic, nathi amagwala nje awalilayo okoko. So we made this one r, it's gonna be 4 and minus 3. So let's just draw this tangent. It's from the from the second quadrant, so more or less something like that. So we're going to assume there is our point Q, which is minus 10 is to 12, okay? And then of course we know that the tangent always meets the circle at right angles, right? Yes, it's still the story. But then we're going to have a hypotenuse line here that joins these two nicely. So this is a right angled triangle. Essentially, we know that the radius from above, what did we work it out to be? Square root of 40. So we know that this is square root of 40 over there. And essentially we've got these 2 points, so we will be able to use the distance formula for the hypotenuse. And because we are supposed to find the length, so this is the length, that is the question. So again, with a sketch it makes life a lot easier. Without a sketch you may start to sweat. Okay, so we know that essentially from what we've got here, we can easily say essentially, what am I gonna say here? We can say the radius of the circle r is equal to the square root of 40. We need to make mention of it because it's important. We know that also we are looking for QR. QR is going to be the square root of x at r minus x at q all squared plus y at r minus y at q all squared. So masenze ke bantwana basekhaya, x at r is 4 minus that one is minus 10. It's going to be plus 10 now. Plus here, this is minus 3 minus 12 all squared. So we're just going to set up a simple thing, Pythagoras. Stuff that you learn in grade 9, I guess. I don't know now, things have changed. Maybe you learn it even earlier. 4 plus 10 squared plus minus 3 minus 12 squared. So this gives us the square root of 421 units. Okay, that's not a problem. That's not a problem. Now, folks, once we've got this, we have a story to tell. We can say then the tangent in terms of the length. We can say L tangent L10 squared plus the radius of the circle R all squared should give us OQR squared. Is it not so? This is Pythagoras now. This is from Pythagoras. So be very creative. So the length of the tangent squared plus the radius squared, this is square root of 40 all squared is going to be equal to, this one is 421 also squared. So we can say therefore the length of the tangent is going to be the square root of this shenanigans. This one 4 don't let it lapha anymore. This is 421 this is 421 all squared minus that one here. This This is the square root of 40 squared. Okay, maske siyenzeke le nto. Isisicefe injalo 421 minus that 1 square root of 40 also squared. So I'm getting here the square root of 381 units. Okay, bafethu mina ngiyeka khona la. Xa uthanda ungayi-rounda off to 2 decimal places. So that's not a big question, but it was the only thing that makes it interesting is that you didn't have a sketch. And without a sketch, you wouldn't know that you are looking at a right-angled triangle to sort this mess. Please, guys, be in a habit of trying to picture what you are dealing with so that you don't sweat too much. Again, this is very important to state, and to get to that, it's very important. The substitution into the Pythagoras theorem equation, essentially, and the answer. So here they started you with some heavy questions. Now let's get to 4.2. Now the circle with center T, okay, and equation. So can you see with that equation, we know that the center T is going to be 3:-2 as well. And then, of course, we know that the radius is going to be 5 because that's the square root of 25. So we know that this one is 5 units. And then we can tell that T, the center, is going to be 3:-2. So you are learning this from the equation. Is given below. B is the y-intercept of the circle, so that's fine. We know that x is 0, and then the sum y value we need to find. Not a problem. Again, when they give you this question here, they don't give you so much. So you just have to deal with the questions. Determine the coordinates of B. That's easy. We know that this is the y-intercept. So we're going to use that concept of y-intercept. So 4.2, we've got 4.2.1. We know that for B, being the y-intercept of the circle center T, it is such that we know that x is a 0, so we've got 0 minus 3 all squared plus y plus 2 all squared equals 25. Right, now this implies what? We are going to say y plus 2 all squared is going to be, this is 9, 25 minus 9 is 16, which also implies that now y plus 2 is going to be plus or minus 4. This is when we take the square root on both sides. And therefore we know that y is either going to be equal to, when you take y and a positive 4 minus 2 is going to be 2, or y is going to be minus 4 minus 2 is going to be minus 6. And we can see B is above the x-axis. So we can say here safely, therefore y at B is a 2. Therefore B is this point 0 and 2. Nice and easy. Nice and easy. So essentially substituting 0 there is important, and I suppose with these two equations selecting that one is important, and I'm trying to figure out now what the hell, why is this thing 4 marks? Because I'm like some belief doch. So essentially maybe we're getting 2 marks there for each one. Because ayenzi sense yonke lento. Anyway, let's move on. So 4.2.2. So finally bekhona abantu esibafinyisa igazi ke manje. Sibafinyisela igazi ngoba bayasijwayela. Basuza i-questions ezingenangqondo, bafaka i-marks eziningi. Hayi. Write down the coordinates of C, okay? if C is the reflection of B about this line. But now what do you notice about that line? That line essentially cuts through that what is this thing called? Yes. Yo, Nkosi yami, sengihlanyisa wena. Ngengcono ndizenzele iline yami nobikoso. Ngoba ngizama ukuyenza kahle iyangijwayela. So this line is x is equal to 3 because can you see it cuts through the x coordinate of that point T. So we are told here we are reflecting this about this line. So this means from B to this line, we need the same distance from that line to that C. So what is that? That was 0 to 3. So this is 3 units. So we're going to move yet another 3 units to get to C. That is very nice, because now that means our C is going to be 3 plus 3, that is essentially 6. But now the y coordinate, because it's a horizontal reflection, the y coordinate is that of B, which we found to be 2. So this one you can do by inspection, as the question says, write down. So we can see that C is going to be 6 is to 2. Easy stuff. Easy stuff. So we're getting 2 marks for each one of those 2 coordinates. So 4.2.3 says now another circle with center M. Yo, hi, anikhathali nina. Nini nisibuza ngo. Yo, nithi abantwana mabagqibe kanjani ukubhala le nyaka into kanga. Ayisuka sandlala ngabantwana. X minus 12 all squared, y minus 10 all squared is equal to 100. Again, if this center M is going to be stuff like this, 12 is to 10, and then the radius is going to be 10 as well, right? Because it's going to be the square root of 100. So it says calculate the distance Tm between the centers. Okay, so that means this circle, it has positive stuff, right? So yeah, ne mhlambe into enje, because asazi ngokuthi zikhiphani. Hayi, awuthi singazisokolisi ma. Let's just do this one easily. So this is A. What do we know? We know that circle T being x minus 12 all squared plus y minus 10 all squared equals 100. We know therefore that center T is going to be 12. Oh no, what are you doing? Circle center M. So this is M, is going to be stuff like that, and then the radius is just going to be 10 units. Nice and easy. So now to find Tm, Tm is going to be the square root. So doing the distance formula here is going to be x at M minus x at T all squared plus y at M minus y at T all squared. And then we substitute easily. X at M is 12 minus x at T, which is 3, plus y at M is 10 minus y at T is going to be plus 2 all squared. Okay. So hayi bethu intonga bafowethu, bethu intonga la babuza umphelo. So ke sakwenze njani umsebenzi wethu ukuphendula? Asivele sibe sesiyaphendula. So this is 15 units. Even allows the questions, we just have to keep answering. So substitution, answer. Easy 2 marks, ne? B. The question says, does these circles touch or intersect each other? So if they touch, it's just one point. intersect, meaning maybe 2 points or so. Now we know, guys, that if we've got a circle and perhaps another one, and then they touch, as in they only intersect at 1 point, we know that the distance between their centers is equal to the radius of this circle plus the radius of the other circle. This is when they touch at only 1 point there, right? Right. And then if we've got two circles still, but they intersect at more than 1 point, we will notice that the distance between their centers, which is, say, I don't know, we're going to say this is circle T, this is circle M. So we will know that TM is going to be less than R1 plus R2, right? So this is the question that we're being asked here. Is it this situation or is it this situation? Now let's just find out what is the radii. So let's just find out RT plus RM is going to be that one with T. We saw that it was 5 units plus this one is 10 units. So this is 15 units. We can say therefore the two circles touch at only 1 point. 1 point in their circumference, since we can see that TM is equal to RT plus RM. Okay, that is it. We're done. We are done. So essentially, this calculation is important and this conclusion being correlated. So 22 marks, being a cry nice, I think these two questions took the crown because they are a bit silly. The rest was pretty straightforward, I suppose. Okay, but khalisile baphinde baxolisa kancane, but inkinga la bakushaya ngesikhathi. Okay, let's go to trigonometry. Izinto ezaziculwa ngabo-Dobby Gray laphana, bathi bona they don't know about trigonometry. I don't know about algebra. Hey, amadoda ayithanda ukucula ne, ayithetha izinto ezininzi. Let's go, guys, not a big deal. 5.1 is the stuff that you guys know and handle very well. So if sine 38 is P, determine the value without using a calculator. So 5.1, we know that sine of 38 degrees is equal to P, but always show this as a ratio. So when P is standalone, it's P over 1. So this means our terminal arm diagram is in the first quadrant. So 38 degrees is an acute angle in the first quadrant. So that is why we know things are going to look like that. Y, the origin. And then of course we've got 38 degrees piana. And of course you always work out the other angle as well. If this is 38, this should be 52 degrees, right? It's a complement to it. So this, you don't need a second invitation. Now let's see, sine is defined as opposite. So that's P over 1. That's the standard circle with a radius of 1 unit, essentially. And we know that x squared plus y squared is equal to r squared. We learned that from Pythagoras. So we want x here, x squared plus, instead of y, we're going to put p all squared, and then here we put 1 all squared. We're going to say therefore our x, it's on the positive, so it's going to be the positive square root of 1 minus p squared. So that is very important, because this calculation you must just do without a second invitation. 1.1.1. It says now cos of 218. Cos of 218 degrees is equal to, this is cos of, we're going to employ reduction formulae. This is 180 degrees plus one of these angles. So let's find out which one. So it's going to be 218 minus 218. I went, man. 218 minus 180, it gives us 38. So this is going to be 38 degrees. Now we can use our reduction formula, same angle, but now this is the third quadrant. It's going to be minus cos of 38 degrees. Now we can use our diagram. It's going to be minus cos is going to be the square root of 1 minus p squared all over 1, which is simply minus the square root of 1 minus p squared. Okay, so that's great. In fact, you may not even show that divide by 1. It's not really significant, is it? But this reduction is key, okay? And then this answer is key, and the other mark is from that calculation. So the first 3 marks is scored like that. So 5.1.2. Cos of 14. So what is 14 degrees? Let's see. Now we don't know what 14 is, but 14 by 2 is 28. So it's none of these ones. But what about 52 minus 38? Yes, it's 14. So we know that cos of 14 degrees is the same as cos of 52 degrees minus 38 degrees. So these questions are always there, guys. That's why sometimes the approach will always protect you. Now here we don't have a choice but to do the expansion using identities. So it's going to be cos 52 degrees, cos 38 degrees. The sign changes. It's going to be sine 52 degrees, sine 38 degrees. Now cos 52 is going to be adjacent over hypotenuse. So that is p over 2. Over 1 into cos of 38 is adjacent, which is the square root of 1 minus p squared, that is over 1, plus sine of 52 is the opposite, which is this now, 1 minus p squared all over 1 into sine 38. We saw that that was p over 1. And then we just simplify this thing. This is basically p root of 1 minus p squared plus p into 1 minus p squared. So this is one and the same thing. So it's going to be 2p root of 1 minus p squared. Okay, that was a bit of a silly question, is it not so? Yeah, it's very naughty, Bafwet. So this expansion is important, essentially, and these substitutions are important in the final answer. Okay, easy. So 5.1.3 says sine 26 cos 26. This looks like some double angle of sine, but now what is 26? 26 is 52 in half. So we can just simply say this one could have been sine 52 degrees. It's going to be, when we use our double angle identities, it's going to be the same as sine of 2 into 26 degrees, right? Right. This implies that sine 52 degrees is equal to 2 times sine 26 degrees times cos 26 degrees. And now when we divide by 2 throughout, which is always a gymnastic of note, we can say here, therefore, sine 26 degrees times cos 26 degrees is basically sine 52 degrees divided by 2. Now let's deal with this one. So sine of 52, we can see it's going to be opposite of our hypotenuse, which is going to be basically this 1 minus p squared, essentially over 2. That's it. Okay, that was also a bit of a silly question. Guys, as I said, you'll always get a question using compound angles, using double angles, and some straightforward angles. So they will never warn you. So I think if you watch most of the videos I have done on these kinds of questions and how I explained what is your approach here, guys, there's no need to lose marks on these questions. They can only create a bad design like they did last year to get it wrong themselves, but there's no need for you to get it wrong. You just have to use your logic as best as possible. Essentially, technically, you know most. I guess this part is important, and the substitution. The rest is the gymnastics that are a part and parcel of your curriculum, so you need to know how to perform them. Oh, andiyazi ke lenze lapha. Ifuna ukungiqhela kabi. Now evaluate the following trigonometric expression without using a calculator. That's fine. We can handle that. So we've got 2 sine 165 degrees times cos of 195 degrees, all divided by cos 45 degrees times sine 15 degrees minus cos 15 degrees times sine 45 degrees. Now always inspect what you are given, right? Please always inspect. Now you can see here we've got sine 15 and then we've got cos 45, and then this thing is reversed, so it looks like a compound angle for sine, because cosine is always a compound angle for sine. Then that means we need to find how 165 and 195 are related to these angles in the denominator. So what we can do here, so I'm going to apply my 3-step approach without even explaining it to you guys. So this is 2 times sine 165 is basically 180 degrees minus 15 degrees, right? Let me just double check before I overly assume. 180 minus 15, yes, it's 165. So the power of reduction formulae comes into our assistance here. This is 180 degrees plus, again 180 plus 15 is 195. So here we're just setting up our reduction formulae, because always when you're given an angle more than 90 degrees, you have to be able to reduce it into an acute angle equivalent. Now here let's write it in a way that makes sense. Sine cos 45 minus cos 15 degrees times sine 45. So now that we put it in this manner, it makes life a lot easy, because now our task is to just reduce the top. So this is basically 2 into, now this is sine 15 degrees, because sine in the second quadrant is positive, multiplied by, now cos is going to be negative cos 15 degrees, because that's the third quadrant. This is divided by, now we can see this is basically a definitely compound angle of sine. So this is the same as sine of the first angle, which is 15 degrees, minus, that sign never changes, the second angle, which is 45 degrees. So all of that, I'm just doing my 3-step approach quickly. Now when we multiply out here, we're going to have 2 minus 2 times sine 15 degrees cos 15 degrees all over Now this one is basically sine of minus 30 degrees. Nice and easy, nice and easy. Now what do we have here? Well, we're going to still have minus 2 sine 15 degrees times cos 15 degrees all over. This is basically going to be minus sine 30 degrees. Senifane nje ke ndiya-enjoya ke manje befanele basendiyiqukumbele yonke le nto. So negative divided by negative is a positive. So we've got 2 sine of 15 degrees times cos 15 degrees divided by sine 30 is a double angle of the same business there, right? Right. We can either contract the top into 30 or we expand the bottom as basically 2 sine 15 degrees cos 15 degrees, because that is a double angle of 15, and we can see 2 cancels 2 over there, and essentially sine 15 cos 15 cos 15. So the answer is 1. Is done. Of course, I was just enjoying here, guys. So you know, when you're confident, you are confident. What can you do? Nothing. So where are these marks bafowethu? Of course, this reduction is important. That reduction is important. And this contraction is important. This is where your first 3 marks are. The rest was just a setup. Ne. Yeah. And then essentially, where are the rest of the marks bafowethu? Is this final answer for sure? And perhaps this expansion again, if we expanded that into that, maybe this is where the last 2 marks are. So 5 marks in the bag. So let's move. Okay guys, so that was an easy question. So let's get to 5.3. 5.3, we are given k equals k is equal to square root of 3 cos x sine x, and then we are told here, write k in this format. Now we can see here, this was an expanded form of some kind of a compound angle. Here we are contracting it. So obviously, once we see root 3, this already introduces in our mind a thought of special angles, because we know that when we've got 60 and 30 degrees, we get a root 3 over 2. So essentially here we're just going to choose to divide by 2. What you do on the one hand side, you must do on the other hand side. Ne? Yeah, so what we're going to do here, we're going to say k over 2 is going to be equal to root 3 over 2 cos x plus, now when we divide here, it's going to be a half essentially times sine x. So why am I choosing 2, guys? Okay, maybe let me start properly. You know, sometimes then we divide by 2. Why am I dividing by 2? Because I know when I divide by 2, I'll get special angles for root 3. So this is root 3 over 2 cos x plus, now when we divide by 2 and then we factor it out, it's a half times sine x. Now this is going to make a bit of sense, right? This implies that k over 2 is. Now remember, I need to reduce this to a sine compound angle. So now I need to change this angle so that the first angle is something, the second angle is something. And then I know if I'm going to choose sine here, this is the same as sine 60 degrees. Because sine of 60 is root 3 over 2 cos x plus. Now this is the same as cos of 60 degrees, because cos of 60 is a half times sine x. So now I've set up my expansion nice and easy. So this is k over 2. Now let's contract this thing. This is going to be sine of 60, the first angle, plus x, the second angle. And we just simply cross multiply that because this is all over 1. We isolate k, so we can say therefore k is going to be 2 times sine. Let's put it in the way that x is the leading, and then 60 degrees is that one. So that is sorted. Nice and easy. Of course, you can divide by any number, but my plan is to use special angles. So that's why 2 becomes the magical number. Anyway, that was a nice question. This situation here, when we divide, is important. And essentially, to convert these to that is important. And the rest of the final gymnastics is the last mark. Okay, nice and easy. Nice and easy. So we've got here 5.3.2. Says now hence calculate the value of t and theta. I mean, that question is misleading. Just say hence determine, because we can see t is 2. It's this maximum value. And then we know that theta is essentially 60 degrees there. So they could say hence determine or hence write down, but to say calculate, it's misleading. How do you calculate this? It's already there. Hayi man, sanusiqhela. Sanibamba ngezinye izicimamlilo ke tana. 5.3.3. Bese niyovuka ePotchefstroom. Ingathi ingqondo zisipane ncam nalakini nithi sithi amageza kanti nani niyahlanya. Write down the maximum value of k. Obviously the maximum value of k is going to be this coefficient right here, because it would be the amplitude. So we can just say k max is basically equal to 2. Nice and easy. That 1 mark is in the bag. So 5.4. Let's move, guys. Time is not on our side. This thing is long. Now we're proving an identity. So we've got 5.4.1. We've got 2 tan theta minus sine 2 theta over 2 sine squared theta. Essentially, let's just jump in before we waste time. I'm just going to write here the left hand side is equal to that, right? Right, because when we're proving an identity, you always select the complicated side. Those double angles are the clue, because this is already too simple. Then now we've got here 2 times tan of theta is basically sine theta over cos theta minus this one is going to be 2 times sine theta cos theta, and obviously that is all going to be over 1. Right. Now I'm going to expand. That division line is going to be here 2 sine squared theta over 1. So since we're in that mood, we have got ourselves a situation. Now this one we can contract into a single lovely thing there. When the the denominator is 1, I just simply multiply the numerator by that denominator. So this is essentially going to be 2 sine theta minus. Now this one is going to be 2 sine theta times cos squared theta. Okay, and then we divide by the same denominator, which is cos theta. So we're using the LCM technique here. But now I'm moving quick, guys, because I'm in grade 12, right? In grade 12, you're not going to be hanging around the bush. You change that to its reciprocal, so it's going to be 2 times sine squared theta. Right, when you change a division to multiplication, you flip at the thing. Now let's move on, guys. So the next story that we've got here, we've got a common factor, which is 2 sine theta into, now this is 1 minus cos squared theta all over cos theta. When we multiply, actually here is going to be 2 times cos theta times sine squared theta. Let's just complex it nicely before we waste too much time. So the 2 takes out the 2, easy, and then the sine takes out the 1 sine over there. That's great. And then now that is a double angle identity, which is basically going to be spelling out sine squared theta over cos theta times sine theta. Again, this guy takes out that, so we end up with sine theta over cos theta, which is tan theta, which is equal to the right hand side. Okay, sometimes these ones can take a bit of space. I don't know how you guys manage with the little space they give you, which is ridiculous, you know. It's totally ridiculous, but yeah, whatever. We get a mark for that business, and we get a mark for this expansion. Whew, first 2 marks in the bag. And then for now, sorting up this one, you see factorization, it's a mark-worthy step. That's the 3rd mark. Now to sort this out into sine squared theta is the 4th mark. It's important, ne? And then doing the gymnastics is not a big deal, but contracting that to tan theta is a mark, right? So how many marks we've got here? 1, 2, 3, 4, 5. Where is the 6th mark? Where is the 6th mark? Angazi bafowethu, so nani senizozibonela ukuthi ivela kuphi. Bavele baba generous. 5 marks would have been okay. Okay. Now it says, hence determine the values of theta. Theta being an element of 180. So this domain is important, which will make the identity undefined. Okay. So this question is always there. Huh? It's always there. So 5.4.2. We know that this would happen when 2 sine squared theta, which is the denominator, is equal to 0. Right. This therefore implies that essentially here sine theta should be equal to 0. Is it not? Because we will take the square root here. But maybe we can say plus or minus 0. Yeah. But is there a negative 0? No. It does not exist. So let's just not even do it. 0 is 0. So when you sort this out, we get this one. So which implies now that theta is going to be 0, because shift tan 0 is 0. Shift sine, okay, maybe let's write it. Shift sine of 0 plus k times 360 degrees, or theta is going to be equal to 180 degrees minus shift sine 0 plus k times 360 degrees, where k is an element of integers. So I always employ my general solutions here to sort me out. So this implies that theta is going to be shift sine of 0 is basically 0 plus k times 360 degrees, or, don't know why I put a comma there, or this one is going to be essentially theta is 180 minus 0 is just 180 degrees plus k times 360 degrees. where k is an element of integers. Now, what do we do now? Once we've got our general solutions, we can make our conclusion, because we were sorting the values of theta. Theta should be an element of. Now, let's see. What happens to k when k is 1? This is 360. And 360 is within the domain. So k can be 1. But when k is 0, this is 0. But 0 is less than 180 degrees. So that one is out. So we only take 360 from this. Then on this one, k can be 0. It gives us 180. 180 is also part of the solutions. Not a problem. But now, when k is negative, 1, for example, this is going to be 180 minus 360, which is going to be minus 180. So minus 180 is outside the domain. So the only two solutions here is 180 degrees and 360 degrees. Otherwise, anything else is outside what is acceptable. So that is our answers, because we were solving indirectly. And of course, you can decide how you want to do this, but the marks are here, Buffett. It's just those 2 marks. The rest was a means to an end. And we are taking these 26 marks with a smile. Even on my cry nice, maybe this one could make you shake a bit and make you wet your pants a little bit, because you know what? That one can be a bit of a situation if you don't have a mathematical background knowledge. Otherwise, you are dead. Now let's go to question 6, which is functions. Question 6 is the functions. Now, I told you, sketch the graphs of f equals to 2 sine x and g of x equals cos of x minus 30 degrees. Again here, the analysis, guys, I often give you is quite obvious. So we know that the amplitude is going to be 2 there, and then the periods are both 360, right? So for the period is 360. And if that is the case, we're going to say 360 divided by 4 for our intervals, which gives us 90 degrees. But because this one is shifting 30 degrees to the right, we are going to have to split this into intervals of 30 degrees. So essentially, we're going to use 30 degrees for our intervals, because then that means it will accommodate every single function we've got. So that is as easy as that, because the key is finding those intervals. Now we're told you from minus 180 to 180 on the grid. I really don't have that, so we're going to make our own. Excuse me for that. All right, so 6.1. Let's just do our own grid. Okay, guys, so I've created my grid, nice and easy. So now let's start plotting. Now the sine graph, we know that sine of 0 is going to be 0, right? So it's over there. Yes, and then from here, what are we going to do? The critical values are just the normal ones. For sine, it starts with 90, so at 90 it goes to 1, but now because it's 2, so we're going to go to 2 at 90, right? Right. And then at 180 it goes to 0, flat. Nice and easy. And then again at minus 90 it's gonna go to minus 2. Of course, guys, I don't have a ruler, so my thing does not accommodate. So let's draw it. Okay, so that's the sine graph. So that is f. Okay, that one is sorted. We don't have a problem with that. It's nice and easy. Now let's get to this one. This one is a bit silly. Remember, cos of 30 is going to move. What happens at 0? It would be 1, right? But now it's going to happen at 30 degrees. So this one at 30 degrees is going to go to 1. Maybe let's use this color. And then now what happens at 0, because that's a y-intercept is important, it's going to be cos of 30. And then let's see, cos of minus 30 is basically root 3 over 2, which is 0,9. So this one is crossing just before that. But maybe let's make it a bit silly and say there it's going to be crossing. So once we've got the y-intercept sorted, it's fine. We know that cos of 90 was supposed to be 0, but then that is going to delay 30 minutes. It goes to 120. 30 degrees to the right. And then the end, what happens at 180 is what was going to be happening at 150 basically. Right. So that is essentially, the ends are very tricky. You don't focus on that. You focus on this one, because this one is beyond the domain if you think about it. So now to get to 180 is what was supposed to happen at 150. So we're just going to say cos of 150. It gives us a minus root 3 over 2. So this one goes to that point over there. Okay, so now this end of the cosine graph is sorted. And then we know that what was happening at 90, which is 0, is going to happen 30 degrees later. So that is going to be at 60. And then what would be happening at, say, where do we get a minimum, Kanen? We get a minimum at 180. So 180 will take us to a minimum of minus 1. 30 degrees later. So this is going to take us to minus 150. And then now what will happen at 180 is what was going to happen 30 degrees earlier. So all we simply say is just minus 180 minus 30. It becomes 210. So this is basically cos of minus 210. And then we get a minus 0,8. So at this one here, it goes to something like that. Alright, so now we just join our graph nicely. So there we go, guys. So we've got our graph of G. Nice and easy. So of course they're not going to look the very best, but it's quite nice and easy there. So what I would do here, because we were told to show the maxima and minima, so what I like to do is to show these ones, because I don't like to write coordinates. I really don't. So what I'm gonna do here, I'm just gonna do this business right here, and then of course accentuate my 2, and then here I'm gonna do the same. And then that is the story. So essentially that is sorted. And then of course it's not to suggest that this is the only way to do it, but I'm just doing it this way, okay? So don't be asking me silly questions. Otherwise ngizonigqoba mina. Ngizovele ngigqobe impela. So uma ungafuni ukugxothwa yimina, usuzongiyekela impela, uyangiyekela nje. Okay guys, so what are they saying here? Yeah, we are showing the turning points. We've shown everything, the intercepts. Maybe here we need to indicate that one. This is 0,9, né? That intercept there, because that one is not quite clear. The rest is obvious. Now folks, we are sorted here. We are essentially sorted. Now those are the graphs. So we're scoring how many marks? 6 marks. Wow. So that one is done, guys. It's done. Okay, time is trying to run away from us. So let's do 6.2. So those are going to be the interpretatory questions. So it says use your graphs to answer the following questions. 6.2.1. Write down the period of G. As we can see, the coefficient of x is 1. So the period T is going to be 360 degrees. Easy. So 6.2.2 says now determine the values of x for which f of x is greater than g of x. So essentially, when do we see f of x greater than g of x? As we can see, f of x from that point and all in those areas is above the graph of g, right? And also in this segment right here. So that is essentially the story. Ne? That is essentially the story. And I'm sure this point is actually capturing both. Sekwenzeke izimanga apha. Kuvele kwenzeke izimanga. I'm sure that point is here fun. Let's see. 2 times 2 into sine of minus 150. What would that be? It's minus 1, yes. So this point right here. Masiyisuse siyenze isilante kancane. Because inkinga zethu zizobaningi la if asikwenzi kube sengathi kuyafana. Yabona makunje manje sesiyakhuluma ke manje because that point is actually there. Sihlangana lapho. So be careful. Kula grid ke abakunike yona uzokwazi ukuyibona because awuzuyibhuda. Le into abantu vele ndazikalela njengamehlo, yabo. That's why izinto ezingathi sifuna umqhela kabi. Anyway, now we can see there that this is essentially during that interval between 150 and 180, and again between this interval. Even this one, if bekuthiwa lento siyenze kahle, I'm sure nayo le. It's not the way it looks actually. Nayo le, I'm sure apho sihlangana khona sihlangana la. I'm sorry guys, my sketch is a bit silly now. It's starting to irritate me because we know that sine of 30 is a half, right? Sine of 30 is a half. Then when you multiply half by 2, it gets to 1. Yes. So ziyalingana pa. Ne? Ziyalingana pa. It's just a matter of my sketch. It's not exactly on point. Anyway, so we can see now that the first interval is this interval right here. Okay? That's the first interval. And then the second interval is from 30 to 180. So it's this long interval. Okay, so to answer this question, we know that our x must be less than minus 150 degrees, but greater than minus 180 degrees, comma, we know that also our x must be less than or equal to 180 degrees, because even when they are equal, that one is less. Greater, this one has to be greater than 30 because at 30 is yalingana. Greater than 30 degrees. Actually, I need to adjust this one. Koni adjustment la. So we are saying greater than x, but even actually at that point in Dalalia. So I think that is where the trick is for this one, which is why it's going to be 4 marks, because it's going to be 2 marks for including those and then 2 marks again. So it makes a bit of sense to be 4 marks. Okay, all right. So 6.2.3 it says now determine the values of f of x equals 1, 5 plus that. So essentially what we do here, we're just going to write f of x equals 1, 5 plus g of x is suggesting that we are saying f of x minus, you transpose this, g of x must be 1,5. So we are suggesting that y values of f minus the y values of g, we must get that. So where is that going to be evident? Okay, now let's scan through this business here. Let's just choose another color. Now, what is important is knowing your graphs very well, because this question is a silly question, I'm telling you. It's not those questions that, you just enjoy. These are the questions that are there to cause you a bit of uncomfortable space. Now, let's look at f of x. Look at 90, for example. This is 2. And then this one is exactly at a half, essentially. That is at a half. Can you see 2 minus a half, which is 0,5? It gives us a 1,5. So this is here. It's happening there. Number 1. That story there is happening. Great. Then let's look again. If you look at 150, for example. At 150, this one is supposed to be minus a half. Let me see. Cos, let's say here, cos of 150. What is that? What is that? It's minus 0,8. It's not doing the things, ne? Yeah, but anyway, here 150 is going to be 150, actually minus 30. And that's by why it's going to be at 120 there. So cos of 120 is basically minus a half. Yeah. So this one at 150, it's exactly at minus a half. We're going to be sketchy some bit as a slanga. So that should be over there. Minus a half. But what is this one at 150? It seems like it's sitting at 1 as well. Ne? Yeah, it looks like at 1. So let's see. What is sine of 150? It's basically a half. And then we multiply that by 2. It's definitely a 1. Now remember, 1 minus a minus 0,5 is going to be a 1,5 as well. So we know that at this point of 150, again, that difference, it's going to be this one minus a negative 1. It's still going to be a 1,5. Can you see that? So those two areas are easy to spot. Here they are equal. It's not going to happen. And then other areas are really crazy, man. You don't want to worry about them too much. But let's see. Here at 90, these ones are negative because this is negative minus another negative. It's never going to give us what we want. It's not going to work. It's not going to work. I think it's not going to work. So again, there's 2 marks, so probably 2 solutions. I think those 2 solutions are the best. So we can say therefore our x is either going to be equal to 90 degrees or x is going to be 150 degrees. Because at those 2 points, this is happening. So technically getting a mark for each one. But this was just your thought process. Because if you did not arrange it in such a way that you can see it's going to work, you're going to be dead. Yeah. You're going to be dwarfed. So again, this last question is definitely a higher grade question because it's not so easy to see it. It's not so easy to see it. So I'm a cry nice. Thank you very much. You've been a star. So see guys, there's nothing to fear in paper 2. So let's do question 7, which is the 3D stuff. The 3D. Now you know here. You apply everything you know, guys. I'm not gonna go over it too much. Just solve. We are already out of time. In the diagram below, PQ is a vertical mast. Now we can see that it's perpendicular to some horizontal. R and S are 2 points in the same horizontal plane. So normally we shade. Okay, so they normally shade, but I don't know why when I shade. So they shade it. So when they shade it, it's in the horizontal plane, same horizontal plane. Okay, so essentially the must, I think he'll ante a flag must, isn't it? Yeah, something like that. Anyway, QRS is equal to alpha, we can see that, and QSR is beta, we can see it, and SR is equal to 8 minus 2x, that is indicated. SQ is x, it's indicated. Now the angle of elevation of P, the top of the mast from R, is theta, so that is also indicated. So all they spoke about is right here in front of us. Now we need to decide, where do we begin to solve anything? Well, we will see. Express PQ in terms of QR. We want PQ in terms of QR, all right, and a trigonometric ratio of theta. So they're already telling us we are starting here. That's a right angled triangle. So 7.1, we know that in triangle PQR, now we are looking for PQ. We've got the adjacent QR. So that's a cos ratio there. So cos of angle PRQ is going to be the adjacent side, which is QR, over the hypotenuse side. Yay when sunqhela, that is the wrong choice. Yay jwayela kabi uzokhetha cos bantoni apha sina hypotenuse side, we don't have it. So this should be 10 of that angle PRQ, because now that would be opposite, which is PQ, which is what we're looking for, over adjacent, which is QR. So that's better. Then we simply substitute. So this is 10 of theta is going to be equal to PQ, which is our interest, over QR, which is also supposed to be left the way it is. So this is over 1, so we cross multiply there and we do the division. So we can see that PQ is basically going to be QR times 10 theta. So we have expressed it as some product of QR and a trigonometric ratio of theta. So that is easy, guys. So you're getting a mark for this one. It's too simple. 7.2. Says now show that PQ is this lovely shenanigan. So guys, always inspect what you've got here. You've got X. X is part of this triangle here. And then the next one, we've got sine of beta. Beta is part of this triangle. Can you see? And then there's this 10 theta right there. But 10 theta, we knew we got it from finding that PQ. So that is where the 10 theta came about. It's in the other triangle. So we just leave it. It's an odd one out. And then we keep going. Then we see there that we've got sine of alpha. Sine of alpha is in this triangle. Can you see? So we've got a lot of sines and a side on this triangle. So that means we're using essentially the sine rule. But as you know, from any approach into these situations, you always calculate all possible angles. So that angle needs to come out. So this is going to be 180 degrees minus the sum of beta and alpha. Okay, that angle is important. Why am I fussing about it? Well, maybe I need it, maybe I don't. We will find out. So let's see. We are going to say now we can see that this is triangle QSR. This is where we are. Do we even need that one? I don't think we do, because PQ is part of what we want. And then QR is there. But now QR is a bit different, eh? There's no QR. But I'm trying to think. How do we... we just need to find QR. I guess QR is the question mark, technically. Because we've already got PQ. So if we find QR, it means QR has to be x sine beta over sine alpha, because that 10 theta is already from there. So from inspection, you can see, I'm going to use sine rule. Now I'm here and I'm looking for QR to substitute there. So what do? We don't need that angle because we have been given beta, which is opposite QR, which is what we want. We've got alpha, which is opposite side QS, which is X. So we've got what we want. So we don't need that angle so far. So we can just simply say sine. By the way, we're looking for QR. So let's just say QR over sine. The angle opposite that is going to be angle S is equal to, and we're going to say QS over the sine of angle R. Again, we stated which triangle we're talking about. So that is the sine rule, okay? This implies now QR is what we want over sine of S is essentially sine of beta is equal to QS, which is X, over the sine of R, which is alpha. Then we just simply cross multiply, then solve for QR. We can say therefore QR is equal to X sine beta over sine alpha. Can you see your inspection already led you to exactly what you're looking for? Now, what do? We can say here, therefore, PQ is going to be, instead of QR, we're going to write X times sine beta times the tan of theta, all of that over sine of alpha. All right, we're just saying sub QR in the answer, ndivele ndibhale nje amasongololo, in answer of 7.1. Sometimes you don't want to say too much, you just say a little bit. Amachera wayefuna indoda ethetha kakhulu, so ingabi ngo-logoric guys lapha, gqibela senithambile makwedini. Anyhow, let's move. Ndiyabazonda abantu abathambile mina kuqala, so andibafuni nokubabona. Nabasisi abaphihlikayo andibafuni. Funa amantombazana afeisty kabi. Into ezinezi, not amantombazana, amantombi, because mina ngamantombazana ningabantwana nibancane la. So ngingabheki nombheka. Ngibheki nokunibheka nami. Asibhekani mina nani. Siyaprotectana instead. Yabo? Ya odade omama benu essentially. No tata benu. Omama benu phela. No ncinci benu mhlawumbe. Yazi ezantombi engathi ukuzibheka, but andibafuni laba abaphihlikayo. Ngifuna lezi zinto ezifeisty lezi. Oh, excuse me. Yeah, those are my type of girls. Andifuna intombazane emathile ethambileyo ezabikhala nasikhathi sokuthuthuzela. I don't have time. Yes, sob stories. Yebo. Now it says if beta is 60 degrees, show that the area of triangle QSR is this one. So that's good. We will fight this long fight. So it's just 3 marks. So essentially, technically, we know that we don't have anything else here except X. So that means we have to choose this side, right? And this side, and this included angle, which is beta. We can use the area rule there. So we can say in triangle QSR, that's just the thing now. So we know that the area of triangle QSR is going to be half QS times SR times the sine of the included angle, which is angle S. So why are we doing this? This is the area rule. Wana yapha bebesenikeza ama-cry nice impela la. The only nto ngibuza imibuzo emuncuka ngayo. question is simple. There's 8 minus 2x times sine of 60 degrees, because beta there is 60 degrees. Yeah, when now we've got a half into, we distribute this thing in here, it's gonna be 8x minus 2x squared. Angazi noba ngenza zona ke impela, times sine of 60 is root 3 over 2. It's a special angle, ne? Masiyeke ngoku. Must distribute this half in there. So this is going to be 4x minus essentially x squared, ne? Into root 3 over 2. Okay, I don't know why I'm just suffering here, but I'm just suffering anyway. So when you distribute that again, we get root 3. 4 divided by 2 is 2, so it's going to be 2 root 3 times x, ne? Yabona, ibhala ngendlela ezokupopanisa, minus, then this one is basically root 3 over 2 and then x squared. Siqinile. Reqedile ntate. Sikwaphetha. Mushumo. I don't know how to say that in Chivenda. Hey, kanifundisa ni Chivenda nina man. Hey. Funa ukusazi nami isivenda lapha. So, essentially guys, this substitution here is an important mark. Now, since this is an algebraic manipulation of some sort, I don't know what we're going to do. Using the special angle is important, essentially. The rest is just algebra. For me, this should be 2 marks, and as 10 benza, even marks as means, but it doesn't matter, guys. Masike sinikeze answer. Go baby sneaky. And the number. Sorry, by Bambega, by Jonge Ganjan. But you will look at the formal guidelines for a more formal and proper thing is. Now, determine the value of x for which triangle QSR is a maximum. Can you see? Calculus, Buffet, calculus. So what do we know? We know that the area of triangle, in fact, let's use area in terms of x. So we know that actually the area in terms of x of that triangle is 2 root 3 times x minus root 3 over 2 times x squared. Okay, now we can say now for area maximum, it implies that the discriminant, which is a, and not the discriminant, but when a prime must be equal to 0, ne? We are deriving, so this one is basically going to be 2 root 3 minus, multiply the 2, there we get root 3 x is equal to 0. That is when we're doing the derivative there. And what are we trying to do here? We're trying to solve for x. It is the story. So this implies, now we take this one, we put it that way, so it becomes root 3x is equal to 2 root 3, right? So I've just rearranged. Therefore, our x is going to be root 3 by root 3 is out, so this is 2 units. Nice. So that is what we were looking for, but where to? So I get calculus. Savele sa derivate nje. Siya derivate or senzani? Siya derivate. Siya derivate or siya derivate. Oh, English. Don't you know the data? Sisiqhela kabi son. Check thula. Anyway, now let's go on. We're getting 3 marks there. So I think the derivative is important and equating it to 0 is important in solving for x. I bafethi bingama cry nice yonke le question, yabo? Cry nice. Now let's get to some serious business. Euclidean geometry. Kawuthi ngisele itiye kancane. Ya sendingutata omkhulu ne. Sekufanele ngiphonge itiye ngokuze ngifunction. Hayi. Yaguga ke kanjani. tenganza guga msinya nje ndimadala mbijana hayi yabafowethu ndiyacela ke khanike ninganijwayeli lapha nangiyenzi nokuyenza le. I did this video. There's a nice video I've done on this theorem. You can just check. I think it's one of my earliest videos that I've ever posted back in 2022. So just check the channel for this one. It's nice there. Otherwise, it's in your textbooks, so I'm not interested in that. So we're going to do 8.2 now. This is where the action is. So question 8. And then 8.1, see your textbooks, see your notes, bafethu ngeke. Soze ndinenzelele ya nabasentanda bafana bam. Niyamangaza nina students yazi niyamangaza impela. Niyazibukela ivideos eziprova lezi zinto, but these things are in your textbooks. This is what you are taught in class as well. Come on guys. Stop depending too much on things that you already have. Focus on stuff that you don't have, which is these questions. Yabona yela, this is a new question usually. Now you may want to have a look at something, but you guys watching a lot of weak stuff and you're wasting time actually. Anyway, whatever you do, oqhele yakhe akabuzwa. Sitsho-ke. Anyway, from a point A outside the circle, can you see? Same point. Now from a point outside the circle, center O, so that is the center. The contour there, two tangents. Can you see now when two tangents come from the same point, what do we know about those tangents? Those bloody tangents are equal, man. AD and AV. Can you see AD and AV are drawn? Okay, AO and VD intersect at M. Okay, whatever. And then we are told also here that BOD is the diameter of the circle. So if BOD is the diameter, what do we know? A diameter subtends a right angle at circumference. So that's the angle at semicircle. Again, these two guys, they divide into two equal radii. So there's a lot of things there to consider. And then we are told here VAD is 40 degrees. So that angle there is 40 degrees. Okay. That's all we are given. So what can we do with this thing bafowethu? Nayazi indaba. This is the tan chord theorem. This one is the tan chord theorem. That angle and that angle is equal to, because you know most the tan chord. The tan chord is telling you the chordal stuff, and also this one is also the tan chord theorem, and that one. And we can see that essentially because this triangle was already an isosceles, so those two are going to be equal and equal to that. Okay, that is about what we can do here. And then yabona ke leni into iyacaphukisa ngoba zibaninzi izinto. So maybe this is the chord, not the chord but the radius. This is also the radius. I'm not going to use this line because it's produced. It's going to cause us a bit of havoc and it's not useful. It's hanging on its own here, so there's no need to indicate that. So you can already see that there's a lot of angles that are equal. If that angle is this one, then it means also that angle is that one. Can you see that? Yeah, yabona yoma seyiqala baclattered sekuba kubi ke manje sekuba ninyakanyaka eninzi. How do I know that V1 is equal to B? It's an isosceles triangle there because the radii are equal. And there's a lot more. Out in his highlighting zona kanje. That angle bafowethu ilingana naleya. Can you see? Because that is also an isosceles triangle. But yabona ngoku sekuyamosheka asiyeke net so. Sesiyekile ke manje. Let's get to the questions. It says prove that quadrilateral V of order is cyclic. nathi Vodacom dot masipala ke le network yayikade right qha bazi-crooks labantu bafuna udla imali zethu bazamile udle yami anibayekanga sabaclaimela i-billions baze bangavuki emaqandeni nje bazoyibona ingxaki. MTN is becoming an angel. Vodacom is going out. Stupid. Anyway, aske sibayekeni bedom benjalo. Anyway, prove that this Voda, which is VODA, is a cyclic quad. So how on earth are we going to be able to prove this? To prove this thing? How do we prove this thing? Now we can see it's just 2 marks. It just suggests that there is not so much that we need to do. We just need to see what we just need to see. You know. Okay, Bafwet. Now I'm trying to figure it out. For us to prove a cyclic quad, essentially, we can choose to find angles in the same segment. Let's say if we prove that this angle right here and that angle are equal, if we can prove that, then we can say the angles in the same segment have been proved equal, and essentially that can work. But this doesn't seem it's going to work, but we can only apply once we are done. But what do we know? We know that the tangent meets the radius at right angles too. Can you see that? And what else do we know? Because now let's remove this one and say again, we know that the tangent meets the radius at right angles. Because lenenye ifuna usiqhela kabi nayo kodwa singayiveza nje. Yabo singayiveza nje. Continue kakhulu. Then sibese sibuyisa izinto zethu esizifakile, yabo? Bese siyazibuyisa ke ngokuzonke. Sibuyisile yonke into ne. But as you can see, guys, this is 90 degrees, that is 90 degrees. So the exterior angle is equal to the opposite interior angle. So that makes this guy a cyclic quad. Okay. All right. Okay. So that is why it's 2 marks. It's not so much. So we've got 8.2.1. So what do we know? I know without a shadow of a doubt. Actually, why did I choose that outside angle? Because now I don't have a way of naming it. Maybe I should just choose the inside angle. Say V1 plus V3 is 90 degrees. Yabo? Is also so that velocity opposite angles of a cyclic quad are supplementary. So we know that V1 plus V3 is equal to 90 degrees. What is that? This is the 10 red story. Tangent is always perpendicular to radius. Ne? Also, we also know that angle ODA order is also 90 degrees. Why? Same story, 10 red thingies. So we can say, therefore, we know that angle order, so angle ODA, and there's a cricket, isn't it? Is it ODA? Something like that. Plus V1 plus V3 there. I got a sanebona on palisynthesis ngeko. Yewena sungihlanyela. That is V2 man and 3 man. Yewena man. V2 plus V3 there as a unit is going to give us 180 degrees. We know that each is equal to 90 degrees. It's quite obvious. So if that is the case, we can say therefore now Voda is a cyclic quad. Why? Because we know that the converse of opposite angles of a cyclic quad. Why? We proved that they are supplementary. Normally we are told it's a cyclic quad, therefore the opposite angles are supplementary. Now we proved the supplementary state of those opposite angles. Conversely, that should be a cyclic quad. Done. Angazi why benikeza ama 2 marks labantu. Basiqhela kabi. This statement and the reason is important. Maybe for those two you're getting 1 mark because you're just repeating yourself somehow. But maybe 3 marks would have been fair though. 8.2.2. It says calculate the magnitude of O1. Hey, banayo manje 2 marks nayo into ezincinci. But anyway, since we have proven that, okay, that this is a cyclic quad, can you see this is an exterior angle of a cyclic quad? That is an exterior angle of a cyclic quad. So O1 is going to be equal to A1 plus 2, which is 40 degrees. That's an exterior angle of a cyclic quad. So those 2 marks are pretty easy. So we can say angle O1 is equal to, what did they call this angle, by the way? VAD is equal to VAD. This is an exterior angle of a cyclic quad. You can even state in 8.2.1 because that's what we're talking about. Therefore, the size of angle O1 is 40 degrees. Nice and easy. So essentially, guys, that statement and getting the value is the stories there. So let's do 8.2.3. It says now prove that BV is parallel to OA. Oh, BV, where are you, BV? So we're looking for this BV dude. We are saying, is it parallel to OA now? This guy. So ngumbuzo ke lo umile, is these 2 guys parallel? Now we need to be very skilled indeed. And obvious, we will be skilled because we are very skilled. So the technicality is that this angle B is equal to this angle, say VDA. Why? 10 chord theorem. But this angle VDA is now also equal to this angle as a result. How come? These are angles in the same segment, subtended by this chord VA. But does it help? But what would help me is not necessarily that angle, because that angle is not helping. It's going to go us a long route. Let's take another curve. The other curve that we can take is that we know without a shadow of a doubt that this angle right here, that angle is equal to that. These are angles in the same segment, subtended by chord DA, since this is a cyclic chord. But we know that V3 is equal to B. And what is that? 10 chord theorem. Therefore, angle B is equal to O3. Now, these are corresponding angles. If corresponding angles are equal, then the lines are parallel. So what are we going to start? We're going to start by saying actually O3 is equal to V3. Why? These are angles in the same segment, subtended by DA in Voda. We know that Voda is that cyclic quad. We've got a but. We know also that V3 bafowethu is equal to angle B. That is the 10 chord theorem. We can say therefore O3 is equal to angle B. Y each is equal to V3. The third division of the trigeminal nerve for facial sensation and more. Also some muscles of mastication so that I can be able to chew my food, man. The pterygoids and the masseter. Hayi sengiyaphapha ke ngoku, suphapha ndoda, susiphaphele. Ufuna ufana nababhuti abaphaphayo ngoku, indoda ayifanelanga iphaphe ne. Okay, I apologize. Now, what do we know, guys? We've proven that O3 ufana no B, and those are corresponding angles. So we can make the conclusion that therefore BV is definitely parallel to OA. Why? We can say here converse of corresponding angles. Because normally we are told these two lines are parallel, then we say the corresponding angles will be equal. But now we proved the corresponding angles to be equal, and conversely, those lines are parallel. Nice and easy. Okay, so that is great. So I think that is a very strong statement. That is a strong statement, essentially, technically, and enormous. And this link is important. And the final answer, maybe with the reason. Bakhe babe generous xa bethanda. Bebengayeka nje ku-4 marks le nto le, but akunandaba. Ama-cry nice nje, ama-cry nice. Into ezikhala kahle. Sesidlile ke laphana. Awuthi size la. Le nto le ninde man. Yo. Yazi ngibani ixesha abantwana ndini. It's now 24 minutes past 2 in the morning, and le ndoda kusafanele ilali iyosebenza. Niyazazi niyazibona ii-sacrifices esinenzela zona abantwana ndini. Nibe seniyabheda ke nina maniqeda lapha. Yazi banibheda kanjani? You're not sharing this information, because guys, it's for you all as students in this country who are sitting for your matric finals. This is for you guys to get better and better and better. It's not about just getting a distinction. It's just understanding the subject so that you can be able to apply it in other fields where maths is actually applicable. And you can simplify our lives. You can design, equipment with engineers. Even if you become a doctor, you can work alongside an engineer, and design a microscope to operate on the brain, to see better the blood vessels on the brain. The magnification we are getting right now, it's good, but it can be improved, you see. Sometimes you can work with these guys and oncologists to design, x-ray treatment for cancers and stuff that are deep in the body so that people can avoid surgery, especially things like the brain. Guys, there's a lot. So when we're teaching you these things, we're not teaching so that we fihle lento. And it's not about a popularity contest either. It's just to make sure you guys don't miss the boat. We missed it because we were not taught a lot of things properly. We just had to figure things out ourselves and also see from experience that, actually, if only we knew this earlier, we would be far, essentially, So bafethu can share lapha, and it's not about me. I don't really care about popularity. It is the least of my worries. But my only interest is to add value to your education, guys, because a lot of people are going around talking nonsense, saying that this education is not good. It's only because they are not good themselves. There's nothing wrong with this education. You can use it and become better. Yes, it does have its own shortcomings. It's always going to be the case for man-made stuff. There will always be issues, but we can always make up for those. With these supplementations. So bafowethu akufundweni lapha. Ni practice and gain confidence and understanding. This is more important than just a statement with a distinction, and yet you don't understand any of this. You need to see it. You need to breathe it. You need to live it. It has to be a part of your heartbeat. Then you can make our country proud by making changes. Now currently there's this trend of people getting degrees, but this country is not going anywhere in terms of development. And I'm worried because now people are just completing studies and warawara and getting gowned and stuff, but are they really changing our country to any effect? That is where my worry is. We have a lot of people who are just conforming rather than bringing solutions. The gown has to bring solutions. You have to wear it with pride, obviously, but we need to know we can expect solutions from you, not just to add to the numbers and you're back into creating problems for us actually. So please guys, it says now complete the following statement. A line drawn parallel to one side of a triangle. So this is the theorem of proportionality. So this is the proportionality theorem. So a line drawn parallel to one side of a triangle cuts the other two sides in the same proportion. Now that is this completed. It cuts the two opposite sides in the same proportion. So that is the proportionality theorem. 2 marks. Nice and easy for it. So 9.1 is done. 9.2 says, in the figure, KL is parallel to QR. So there is KL is parallel to QR. We can see it. M and N are points on QR such that KN is parallel to PR. KN is parallel to PR. We can see it. And LM is parallel to PQ, so we can also see that. A lot of parallelities. PK is 3 units, so there it is. PL is 4 units. And then LR is 6 units. So this is 6 units. And then MN is 1,8 units. That guy is 1,8. Okay, that's all right. And then what are we supposed to do? Let's find KQ. This guy. KQ is nice because we've got, let's just focus on this triangle. Let me just outline it that way. So this one is going to make life easy if we look at it in that manner. Let's just do it. Let's just do it. Now look at this. Can you see that? We've got a proportionality theorem sorted right there. So in triangle PQR, okay, with, maybe let's even state with KL parallel to QR. Maybe this statement is more complete than this one. So what do we see? We can easily say without a shadow of a doubt that essentially KQ over that smallanyana portion there, which is PK, is equal to LR, which is that one, divided by PL. What is this? Prop theorem with KL parallel to QR. So you see, they were asking you to set it up by defining it and then you're applying it. So this implies, now we just cross multiply that one. This implies that maybe let's just substitute KQ over PK is 3 is equal to LR6 over PL, which is 4. Maybe let's do the cross multiplication here. We just cross multiply that alone. Therefore, KQ is going to be 6 over 4 times 3. What is that? So this is 18 divided by 4. Hey, 18 divided by 4. I went. 10 ngathi inkinga nje. It's 4,5. Okay. So this is units. Nice and easy. So easy 2 marks, guys. So that statement and the reason is important in the answer. The 3 marks, yabona iza marks abazifakile pha ezininzi ezingekho necessary. Beyibhalile ke la for a substitution, but anyway, it is singabe sikhalaza bafowethu. Inkinga zethu zininzi kabi. Into yokukhalaza isebenzi. Xa ungumuntu ebomini afanelanga ukhalaze nje kakhulu, but funeka uhlukumezeke kancane ingqondo izovuka, yabo. Now it says prove that QM is equal to NR. Okay, so we are looking to see that this dude is equal to that dude. Okay, how are we going to do this now? Bona ke ngo ingathi ingxaki zethu ziyanda, but sizoyibetha wena ungawari. Sinamaqhinga lento lena, sinamalibaliba. So if we look at this triangle PQR in terms of LM parallel to PQ, maske siyijonge kanjalo sithi ke ngoku in triangle PQR with LM parallel to PR, for example, let's just say PQ. Is it PQ nakanene? Benifuna uyijonga kanjalo nje. Yeah, maske siyijonge kanje PQ. Andazi noba izosisebenzela kodwa maske siye wethu. Sometimes empilweni you just try certain things out because you're not sure. Now we want to find QM, so we can say QM over. Now QM is this one over the big side QR, because these are siqhela kakubi lento eza numbers and is phone. And then we're going to say that over that side, over the whole side QR, should be the same as that angle PL, I mean that side PL, over the entire side, which is PR. Again, this is prop theorem with LM parallel to PQ in that triangle, right? Right. Now, what do we want? This implies that QM over QR, we don't know what QR is equal to PL is 4 over PR, which is 10. Ne? And then we just cross multiply that. We can say therefore QM is 2 over 5 times QR. Okay, that's it. We can leave it at that and say also, you see these 2 marks will make you think it's an easy calculation. Sometimes it's not, you know. It's a matter of just planning your way, however you see it. What else can we say? We can also see that essentially in that same triangle, if we're looking at it in terms of now, say KN parallel to PR, we can see there that essentially NR over the whole side of PQ of QR basically is going to be equal to the KP or PK, PK, over that whole side, which is essentially PQ. Again, this is the prop theorem. With this time is KN parallel to PR in that same triangle. Can you see? Maybe let's remove this dude here. It's going to cause havoc. It's bad information. Now it comes in there and there. Okay, so let's see. We are trying to find NR here. NR over QR is equal to PK is 3 over PQ. PQ, remember we found out OKQ bang 4,5. So it's going to be 4,5 plus 3, so that's going to be 7,5. Okay, and then we just cross multiply QR, so we can say therefore NR is equal to 3 over 7,5 times QR. Let's see what this is. 3 divided by 7,5. Wow, is 5 is 2 over 5. So this is 2 over 5 QR. So can you see? Same konkolos lapana. This is the same concrete. So can you see this? The same thing. So a little bit of planning. We can therefore decide. Therefore QM is equal to NR. How do we know? Each is equal to 2 over 5 QR. Asiyeke khonapho. Eyoba 2 marks yonke le angisenandaba nayo mina. But I'm sure the most important is those values, right? Because the prop theorem has been shown. The answer was already suggested, so it's fine. Those are the 2 marks, guys. So I'm a cry nice nje lawo. Okay, masenze question 10. Hayi kodwa la madoda wadinwa kanti nina ninjani? Hayi. Abantwana nifuna babhale into engenasiphelo. Hayi, no wonder abantwana bekhawatheka nje. How badoda? Aniphezi kanti nina ningabantu abanjani? Ubuza umphelo. Hayi. In the figure, 2 circles intersect at A and B. So there's the stuff there. A and B. And then AB produced meets bisects. AB produced to M. Okay, this line right there. If we produce it to M, it means we're making it a straight line. It bisects QAR. If it bisects QAR, it means this angle here is equal to that angle. Okay, not a problem. Then tangents MQ and MR. MQ and MR, can you see they're from the same point outside the circle? So it means this tangent should be equal to that tangent, right? Meet the circles at Q and at R respectively. Then we know that QBR is a straight line. QBR is a straight line. These are very strong pieces of information because if this was not indicated or stated, we would not be able to use it in some questions that we probably may want to use it for. Okay, then AQ and AR are drawn. Again, AQ and AR. So these are simply chords in each circle. So those are straight lines, not a problem. What can we do with this piece of information? Obviously, without thinking twice, this angle is equal to that angle. R1 is Q1 because 2 tangents from the same point outside the circles. These are 2 different circles. Oh, Nkosi yami, yabona papa kunje. Asifani kaloku. So ke ngoku asikwazi ukuyithetha le language yabo. Masingaphaphelani. Okay. Singaphaphelananga njalo, we can see that if that angle is equal to that, of course, look, this is the tangent, this is the chord, and then it should also be equal to that. Okay, maybe masiyenze ngconywana ngoba ingathi khona ingxaki ezawuvela. So we can just simply say this angle is equal to that angle, while those two angles are themselves equal. Ne? So that angle is equal to that 10 chord theorem, right? Right. And then that angle is equal to that because they are bisectana, ngithi. And then that one is also equal to that 10 chord theorem. Now, only this time, we can say if those two angles are equal in this triangle, it means this side should be equal to that. But because they were going to two different circles, we could not use that tangents from the same point. But it's only because the base angles are equal. Okay, we are happy with that. Is there more we can do, Bafwet? Sometimes it's better to just go to the questions. Do a little bit before it gets overwhelming, you move on. So 10.1. We are told here, prove that triangle MQA and triangle MBQ are similar. Okay, let's find those triangles. Okay, so these are the triangles we are dealing with. This blue one that is outlined, which is MBQ, and MQA, which is MQA. So, yeah, niyaspekasa bafowethu, niyaspekasa manje. So what do we know? We know that angle M1 is common to both, right? Because both of these triangles have M1. And then this Q1 is equal to A there, 10 chord theorem. And then the remaining will be the remaining angles. So that's done. So we can say in triangle MQA and triangle MBQ. What do we see there? We know that angle M1 is common. Nice. 2, we know that essentially angle MQA, we know that Q1 is equal to angle A1. Angle A1, right? What is that? 10 chord theorem. Okay, great. Once we prove two sets, the remaining set is going to be equal to the other. So MQA is going to have Q1 plus Q2. So we can say here, actually we can just say AQM. AQM is going to be equal to B1 in the other triangle. What is that? These are the remaining angles. So therefore, triangle MQA is definitely similar to triangle MBQ because they are equiangular. Okay, so that is great. So 3 marks, guys. This statement and the reason is important. The 10 chord theorem is important. And essentially, I don't know, guys, you get an extra mark either for the remaining angles or for the common one. It just sometimes gets overwhelming. So, yeah, 10.2. We are told here, prove that MR squared. Now, always interpret this stuff here. Where is MR? There is MR there. MR is over there. Can you see? Now we are saying squared. What are we trying to suggest? Now we are suggesting that it's either we have Pythagoras theorem, but now we don't have any right angles here. So it can't be Pythagoras. So what are we doing? we have a common side in similar triangles, and most likely is these dudes. Because once we have the common side, we will always get a square on the common side. Okay, all right, okay. But now it's probably not those ones because MR is a different story. But look at that. We discovered that MR is equal to QM. And you can see QM is actually common to both sides of this triangle and that one. Can you see? So that's the link. This dude is going to link with that dude. So sometimes you always study the diagrams. Don't look at these things too much. Just look there as a direction. Do you need to do more or not? But sometimes keep your sanity. Anyway, now we've got AM. Where is AM? AM is this side over here. Can you see it's definitely a side of this triangle? MB is definitely a side of the other triangle. So we are talking about those triangles, definitely. And the only link is that this guy is replacing QM. So our link here is to use QM and then substitute MR, because now we can see they are somewhat equal, but indirectly so. This is why those marks are like that. Can you see? So it's a bit of a mile. It's a bit of a mile. But let's start with these triangles. What do we know? We know that essentially QM over, now if we're starting with this big triangle, is over which side? Now QM is opposite that angle. This angle is equal to Q1. The side opposite Q1 is MB on the other one. So we're going to write MB is equal to, now obviously I am going to use this MB. I know this AM, sorry. I'm going to have to use AM. AM is this side which is opposite that bigger angle Q1 and Q2. So we know that it's going to be AM over. Now that angle is equal to which angle? B1. We found out that it's going to be equal to B1. And the side opposite B1 is QM. So that is the story. What is this? This is proportional sides of similar triangles in 10.1. Because now we didn't state where we are working, but if you worked and stated those triangles, you would be good. So always don't leave someone hanging. And then here we just do the gymnastic cross multiplication. This implies that QM squared is basically AM times MB. Can you see this puzzle is sorted? Now our last link is to try and justify why MR is equal to QM. That is just the remaining piece of work. Now this is where we start with the stories. But what do we know? We know for a fact that essentially, technically, most, we know that R1 is equal to angle A2. Right, that is from the 10 chord theorem. Maybe, let's not even start saying things like this. Let's put a structure into this and say, but in triangle. In triangle, let's say QMR, because we know we're going to be focusing on this triangle, but in a special way. We know that angle R1 is equal to angle A2. Why is that? 10 chord theorem. In fact, if you don't know the 10 chord theorem, you don't know grade 12 Euclidean geometry, right? Because it's so common. Not knowing it and recognizing it is a crime. Of course, you'll be told it's time up, guys, but yeah, abantu ababuza too much nabantu apukisa. That's not fair, man. Abantwana bazawuthini bangafeyili xa bebuza into eninzi kanga. Nam sendiqoqukile ngoku. I'm actually bored. That's qoquka ngesixhosa, huh? Se ke kgathetse jwale ha ke sa thaba jwale ha ke sa thaba ho hang. Anyway, Why are we doing all of this shenanigan? It's only because we know that essentially A2 is also equal to A1. That was given. That it was given that AB produced to M bisects QAR. So state all of those things. And what is the next piece of work that we want? We can say, we also know that Q1 is equal to angle A1. Again, 10 chord theorem. We can now make a conclusion, therefore, angle Q1 is essentially equal to angle R1. H is equal to angle A1. Because that is the link between these ones. They are equal to angle A1. Imakancinci. Kukhona into endiyimoshile apha. Khona into endiyimoshile apha. Masiyilungise. Sendivele ndaphapha. Njengentaka. Yazi xa usuyifumene impendulo uvele bese uyaphapha. Then here we can make a conclusion that therefore angle R1 is also equal to angle A1, because we need to link these two, and we can see why is the case. So we leave it like that, and then we come here and sort it out and say maybe, however, sometimes those words are proper, and therefore we make a conclusion. And then now once we make this conclusion, we can conclude that essentially QM is equal to MR. What is that? These are sides opposite equal angles in a triangle. What triangle are we talking about? QMR. Now we can say then, then we can see that QM squared is equal to AM times MB, implies that we substitute QM with MR, all squared is equal to AM times MB, therefore MR squared. It's a bit cumbersome, but it's a math essay on its own, essentially. It's a math essay. So these questions are higher grade questions, guys. They are there to not make you happy. They are there to rub you wrong. They are there just to cause a bit of pain in you, okay? Because, it's the stories. So essentially, guys, this is 2 marks for me. It's very important. But now there's these other marks that we need to find. Essentially, this is a very important mark to get to. As for this 10 chord theorem business, it's a bit of a silly situation if you ask me. But I can just simply say you can get a mark anyway in this situation. But for me, the substitution of one by the other is important. That is the 4th mark. And to avoid all these troubles, I will then say directly, because even though the answer is suggested, but somehow it's logically connected to something, or you can get a mark elsewhere. Sometimes to mark these kinds of questions is a bit cumbersome. Almost 10.3. Now we're going to be hit with another situation now. Can you see MQ squared, MR squared is equal to 1. Now 4 marks. Yabona yengonto indenza uncomfortable mawethu. Just a moment. Okay, so andiyazi ke ngoku le nto yenzeka apha, because look at this. We've already proven that qm squared is equal to mr squared, and it's the same thing. So now if 4 marks leba fethu ayenzi sense. I don't know ke ngokuba siye sapapa sajumpa igani na sasebenzisa izinto ebesingafanelanga uzisebenzisa. I don't know, because why is it 4 marks le nto le xa kuyinto eyi-1? Because now for me 4 marks says 2 steps at least, and chances are we probably need to prove some similarity for mr. Yabona ke ngoku andiyifuni ke le nto, andiyifuni. That means we chose a different technique. Now it's becoming a bit silly, because it seems that here we should have just compared these two triangles, you know, the big one and the smaller one. Use that mr as a common side, and then use these other triangles to find this, because this 4 marks is suggesting that we need to use two separate triangles here. So that means our technique, as comprehensive as it is, it's now leaving us hanging, because we've already done what we were supposed to do. And for me, this 4 marks is as good as 2 marks now, because angisazi ke ngobafowethu. So I feel like we shot ourselves in the foot here, because this is a good technique. It's not bad, trust me. But ngoku i-problem yethu is that we've done all the donkey work there. Otherwise here it looks as if they decided to use this mr from this triangle BMR against triangle AMR, because that would still be used for the same purpose. We prove similarity there, then we get this ratio. It could come out 5 marks. Then here we use qm squared from that other one, then we take that ratio. So this is how this question looks like it was structured. But ngoba sesiyijampile igani, andazi soyiphendula kanjani ke bantu. Ikhona ingxaki esesibona uba sizohlangana nayo. Andiyifuni, but ndizavele ndibe skilled mfana, sebenzise kodwa le nto lena ayikho fair man. Yes, ayikho fair. Honestly, ayikho fair, because you can see that we've done all the work actually that we're supposed to do. Now I would just say mq squared over mr squared is going to be equal to, this is going to be am times mb over am times mb. Why do I know this? Just say from above, from 10.2 above. I stopped there because I did a comprehensive approach. You see, sometimes an approach, it's all about what you decided to do, because this, that, and that, this is 1. So this is done. So as for these 4 marks, it's just too easy now. Hey, yabona. But certain techniques will always do things to you, and sometimes they simplify your life, sometimes they complicate it. Because I can assure you, these guys, for this statement now, they decided to use triangle AMR. So that means for this 10.2, they used triangle AMR and triangle BMR. That is what they used, because they will obviously be similar. Why? Because M2 is common. This angle is equal to that angle, 10-chord theorem, and the remaining angles are going to be equal. And then from that situation, we know that here we're going to prove that triangle AMR is similar to triangle BMR as a result, as you can see. Then we can simply say MR from the one triangle AMR over, this one is opposite A2, A2 is equal to R2, the side opposite that is MB, which is going to be equal to, now obviously we know that AM is part of that big triangle, so it's going to be AM over AM now is opposite that angle, which is going to be equal to B4 for that one, and the side opposite that is MR. Now again, this is similar triangles, right? Then we just simply cross multiply there. We can see that MR squared is going to be AM times MB. So it looks like the approach to this 10.2 for them was to focus on those two triangles. And then the last one was just to make sure you link that, and then you do this ratio. So again, the approach is just what can be. Is for me, you would get this 4 marks because guess what, Bafuetu? I'll just mark you because I mean there's nothing wrong with this approach. It's comprehensive, but it answered the question. You get me? So how I see it is how I do it, and no one is going to tell me otherwise. But if that was the case, then you would know that to get this MQ squared, it comes from this opening statement that we did here, from those similar triangles. And then you just take those two, and this one, you do that ratio, you get your 4 marks. So bafowethu, leyo nasesivele nje sayibetha saphendula questions ezimbini at once, because that's what we did. Anyway, let's move on. You won't lose those 4 marks just because it's too easy now. Like you could see, we couldn't see how to get you the full marks. There were a lot of statements that we said. Those statements will add up. Maybe you get 2 marks for this here. You get 2 marks for this, whatever you did here, and the answer. And then the other marks is these other stories, because they would have been told in a separate question. So can you see? Sometimes they will look above for some of the answers that you have provided. Anyway, let's move on, guys. Abantu ababadinwa man, yo. It's 3 a.m. now. Okay, now 11 says triangle ABC is a right angled triangle. We can see, and then ED is perpendicular to AB with E on CB and D on AB. Yeah, we can see all of that. Now AC, this one is 4,8 centimeters, and then AB is basically 8 centimeters. And then we are told here that AD is equal to DB. Not a problem. So if that is the case, this is 8 divided by 2. So this means this is going to be 4 centimeters. And that is also going to be 4 centimeters. So a bit of logic there. You apply quickly. Then it says calculate BC. Correct to 1 decimal digit. This is easy because this is Pythagoras theorem. So 11.1, we can say in triangle ABC, what do we know? We know that BC squared plus AC squared is going to be equal to the hypotenuse side squared. This is Pythagoras. Nothing important there. This implies that now BC squared, which is what we want, plus AC is going to be 4,8 squared equals AB. This is 8 squared. Therefore, BC is going to be the square root of essentially 8 squared minus 4,8 squared. Now we're told correct to 1 decimal digit. So this is a local instruction. You need to adhere to that against the general instruction. Okay, so this gives us a 6,4 centimeters. So the calculator already gives it in 1 decimal place or digit. So essentially here, the substitutions from using Pythagoras and the answer. But this is Euclidean geometry actually. Substitutions don't really carry so much weight, but it's the statements and the reason for it is actually what matters. Ne? So 11.2 says complete this thing. triangle BAC. BAC is similar to which triangle? This is similar to triangles, say BDE or BED. Maybe let's say that. I got BED, triangle BED. And they didn't ask for a reason, did they? They just said complete. Why? Because we can see here that this angle is common. This is 90, that is 90. So these are the remaining angles. So they are essentially equiangular. Okay, so that was easy. So we're just going to write triangle BED. I don't really care how I name it. 11.3 says now, hence or otherwise calculate the area of ADEC. Now we're looking for the area of this one. Oh, or ADEC. The vitamins is ADEC, vitamin K dependent. Anyway, so we're looking for that. So essentially, what do we need to do, guys? This is easy because we can essentially find two things. What are those two things? As you can see, it's 5 marks. It's going to be a bit of work. But as for the big triangle, we know that we found the basal side, which is BC, which is 6,4. We've got the height because those two are perpendicular. So we can use that area of that triangle and subtract the area of this triangle over there. But now with this one, we only have its base. We don't have its height. So we're going to have to use our similar triangles. You see this similarity right here? We're going to use that similarity to find the size of ED. Then we can use this too. So we start there. We're going to say find ED over. Now ED is opposite angle B. Now this is common to the both. So the side opposite B in the bigger one is AC. So it's going to be over AC is equal to. Now we're going to have to use the side that we know. We also don't know EB. So we're going to stay away from that. We're going to use DB. Over. Now DB is opposite that angle. That angle is equal to that in the other one. And the side opposite that is CB. So, or BC. Again, what I'm going to say, these are the proportional sides in similar triangles where in 11.2. So we are being very smart here. Okay, all right, okay. So we have a but here. We've got but. We know that DB is equal to half AB. Why? It is given that AD is equal to DB. So that has to come out. So what is that? This is half of 8, which is 4 centimeters. We can say now safely, this implies that now ED, which is what we want, over AC, which is 4,8, is equal to, now DB is basically 4 over BC, we calculated 6,4. Then we just simply cross multiply that, therefore ED is going to be 4 over 6,4 times 4,8. Okay, that was a bit of work, guys, but it's not too bad. So 4 divided by 6,4 into 4,8 gives us 3 units. Now, what are we going to say? Now what we're going to say here is that then area of ADEC is going to be equal to area of ABC, right, minus area of triangle, you can say DEB. DEB. That is quite evident, is it not so? This one is going to be half the base, which is going to be now BC, times the perpendicular height, which is AC, minus half. The base here is going to be DB times the height, which is ED. Okay, so this is half into BC, that is 6,4, right, times AC, which is 4,8, minus half into DB, which is 3. What DB is to 11, coming, go 4. This is 4 into 3. Now that is sorted. You can go perfect. 0,5 into 6,4 into 4,8 minus 0,5 into 4 into 3. So this gives us a 9,36 square centimeters, because this we're given in centimeters. In fact, I'm wrong to write units here. I'm supposed to write centimeters. Okay. Ayewafowethu. Sigqibile le nto le. And they didn't say round it off to the nearest, so we stick with the general instructions. So can you see, it's a bit of work. Now, what are we going to say about that statement is important, and essentially getting that value is important, and from there getting ED is important. So see, 3 marks is already out there, and then the 4th mark is just the substitutions over here in the answer. So we take those last 8 marks. I don't know why they felt the need to ask this question. I mean, come on guys, there were already too many questions here. Anyway guys, that is it. That is the end of my review with you of a math paper 2 before you do your exams. Now I can focus on a specific question. If you have any, you can request it in the comments down below, or you have my WhatsApp number, you just SMS me those questions you want. Otherwise, I think we've done some justice to this paper, and I hope you were able to learn along. And as you can see, some approaches are golden, like this one here. Our approach here was comprehensive, and it answered 2 questions at once. As you could see, we didn't know where to find the marks, but now we can see that actually we can add those marks that you need onto the question previously. Or you approached it differently like that, it's still easy, and then you use those similarities that we proved above, you combine, you get your 4 marks in the right question. It's not a big deal. Otherwise guys, I hope you enjoyed the video, and you're going to give it a thumbs up. Please guys, give these likes, don't just watch. I can see I get a lot of good views, but I'm not getting them likes, and as a result, these videos don't really get as far as they should. The intention is to help other kids elsewhere, so for them to be able to see this video, it has to be essentially liked, following the algorithms of YouTube. You know, don't worry about me being popularized as a result by then. It doesn't matter to me. I don't even pay attention to that. What matters to me is to add value to your learning, and free of charge even. So your only job is just to subscribe and give it a like and share with your peers, and that's all. It's a very simple task guys. You don't lose anything for doing it, so please do it for the sake of others, you know. All right, see you guys next time. Goodbye.